Ladies and gentlemen, good morning and welcome to the workshop Biodiversity Net for Life. This workshop is a presentation of a joint research activity of the universities of 3 Italian regions who work together to analyze and enhance the typical local products of Italy. So we will have a description of all the research activities and also a moment of tasting of truffles and olive oil. Before starting, I would like to invite for the institutional greetings from the General Commissioner of Italy at Expo Osaka 2025, Ambassador Andrea Vattani, and then from the Rector of the University Urbino, Professor Giorgio Calcagnini.
Thank you very much, Deputy Rector Musso. And I'd like to welcome you all to the Italy Pavilion at Expo Osaka 2025. We're very honored and happy to have with us a delegation of university. I'd like to thank Rector of Carlo Bo University of Urbino, which is Giorgio Calcagnini. Urbino, and of course, and I will also tell you about the other universities that are joining us today. First of all, I have to say something about Urbino, and I want to say to our friends, our Japanese friends who are here today. I don't know if you've already visited the exhibition in the Italy Pavilion, but you will have noticed that the pavilion is inspired by the idea of the ideal city, Riso no Toshi. And this painting, which you see actually from the very beginning in the video that introduces our pavilion, is a painting which is in Urbino. A beautiful painting that describes this ideal city. Now, this ideal city that is portrayed in Urbino has no people in it. I mean, you don't see any people in it. You don't see any plants in it. Nothing seems to be alive. It's just an architectural exercise. So, of course, the challenge for us is to populate the ideal city. And the challenge is also to introduce nature, biodiversity. So what is the ideal city of the future? This is the challenge that we are in front of every day, and the theme of Expo, which is designing future societies for our lives, has an answer from Italy, which is art regenerates life. Now, art, we do not only intend as culture, as music, architecture, sculpture, many things that you can see in the Italian Pavilion. But art is the action of humans on nature, and the actions of humans with nature, and the actions of humans within society. This is the way we intend it. So we go from art means artisans, it means workmanship, craftsmanship, it means design, it means imagination, it means creativity, innovation, engineering. Just behind this wall, we have two beautiful designs by Leonardo da Vinci, engineering and mechanical designs that come from the Biblioteca Ambrosiana. That is what we intend as the Leonardo and Renaissance idea of someone who can be a scientist, an artist, and an innovator. This is our idea. Now, we are in the week which is dedicated to biodiversity. We've had a very interesting visit here in the last weeks by our Minister for Agriculture, Forestry and Fisheries, Minister Lollobrigida. And at that time, we discussed themes that will be covered today. So we have many universities here. Urbino, we said, Perugia, the universities of the Marche, also the Polytechnic of the Marche, the University of Teramo, Camerino, L'Aquila. By the way, you will see, if you haven't visited the pavilion yet, that a whole area of the pavilion, which is the regional area of the pavilion, is currently dedicated to the region of Abruzzo. Università di Macerata, Università del Molise. Molise will be joining us in Expo in the beginning of July. Gran Sasso Science Institute, and we are very happy to have today the World Truffle Academy, which will do a special presentation of gastronomic also presentation of truffle. So we are very thankful to the Ministry of Universities and Research that has allowed us to bring projects by Italian universities in Expo. This is one of the first agreements that were signed by this commissariat, by myself, with the Ministry of Universities and Research, because you see, Expo for us is not just about bringing Italy to Osaka. It's not just about showing our culture, our products, our territories. It's also about showing our network of universities, and it's also about bringing universities here. It's also about exposing students and also academics to Japan and Asia. Because Asia today is the region of the world which most of all thinks about the future and also has a great growth and has very important markets for our companies and for our high quality products. So this is a very important exercise, so we're very thankful to the delegation that is joining us today. So thank you very much, and we look forward to this day of biodiversity, food, and also some treasures of Italian Italian agriculture, and of course biodiversity. We will talk about olive oil. We will talk about cereals, minor cereals and legumes, truffle, which is something that I think we all value greatly. So thank you very much and enjoy.
Okay, thank you, Ambassador, for your words. You said most of what I planned to say. But first of all, welcome everyone here. Buongiorno. Let me remark a few things that were already said. First of all, the importance of network. We created a network among our universities, the one that are listed here, and we won several research projects. And then it is very important because our universities are relatively small in size in terms of number of students compared, for example, to Rome or Milan and other universities. But working together, it's very important, and it allowed us to win several research projects. And one of the projects was a project thought of to bring research outcomes in Osaka at the Expo, and so we thought of we met, we and we decided to work on specifically on biodiversity. That's very important. First of all, because as we know, there are changes, climate changes. And those climate changes will reflect in how we produce, for example, or we grow some cereals or other products. Maybe we have to be very careful because maybe in the future some of these products, agricultural products, will not be available any longer. So we need to work, we need to research in order to save the value of biodiversity. And for this, I have to thank my colleagues, the other rectors of each university, which were very leaned to sustain the project. And second, let me say one important thing, that this is not only a way of showing the outcomes of our scientific research, but it's a way of creating public and private value. And that's a way it's a channel through which we support the territories where we are located. And again, that's very important because in a global economy, a global society, the fact that we created a network will help to create the conditions for our regions to compete more efficiently and with more strength in a more complex and more competitive world. Again, thank you for all of you for being here, and we'll pass the floor again to Fabio, who will manage each single presentation again.
Now we are starting with the 5 sessions of the workshop. As we have said before, this is a work that has been conducted by the universities of 3 regions, Marche, Umbria, and Abruzzo. They are located in the center part of Italy, close to the east coast. The result of this research has an impact because they allow to improve the quality and the sustainability of typical local products. We are talking mainly about agri-food products, and this allows also to think about a healthy lifestyle for people. So this discussion is not only limited just to product, to the way in which products are obtained, but it is also related to life of a human being and the quality of life. So the first session will be about extra virgin olive oil and the olive tree. And the presenters will be Maurizio Servilli, Agnese Taticchi, Sonia Esposito of the University of Perugia, and Davide Neri and Enrico Lodolini from the University Polytechnic of Marche. The second session will be about minor cereals and legumes with Giampiero Sacchetti from the University of Teramo and Giovanni Caprioli from the University of Camerino. Then another session, the third session of the morning, will be about truffle and mushrooms, and the presenters will be Professor Antonella Micucci from the University of Urbino and Professor Maria Benedetta Mattei from the University of L'Aquila. Then at 12:30 we will have a tasting of truffles that will be prepared with pasta and even a wine tasting. And following this, there will be an olive oil tasting. So it will be very interesting to have a concrete proof of what we are talking about. In the afternoon, the first session will be about biodiversity, health, and well-being. And the presentation will be from Professor Paolo Lucci and Deborah Pacetti from the Polytechnic University of Marche, Ancona, and from Pamela Lattanzi and Serena Mariani from the University of Macerata, Professor Lilia Neri from the University of Teramo, and Professor Gianni Sagrantini from the University of Camerino. The last session will be about biodiversity for the sustainability of the agri-food supply chain. And the presenters will be Professor Elena Viganò from the University of Urbino, Professor Elisabetta Salimè from the University of Molise, and Professor Fabiano Compagnucci from the Gran Sasso Science Institute. So this is the program of the entire day. So I hope we'll be appreciate the effort that has been conducted to synthesize the quality and the value of some of the many Italian typical products that make Italy unique, I can say. So enjoy this workshop, and I'm going to invite the presenters of the first session, Maurizio Servili, Agnese Taticchi, and Sonia Esposito from the University of Perugia, please, and Davide Neri, Enrico Lodolini from the Polytechnical University of Marche.
Good morning, everybody. The first part of our presentation will be divided in three speakers. The first is my presentation in the general characteristic of extra virgin olive oil. The second one are produced by Professor Esposito that are related to the variability of the composition of extra virgin olive oil according to the agronomic and the technological condition of production. The third, its relay is produced by Professor Taticchi and are related to the utilization of byproduct and the valorization of byproduct of olive oil extraction. When we talking about biodiversity and sustainability, the use and the reuse of byproduct is very, very important. The first point that we can discuss relate to the extra virgin olive oil. What is olive oil in particular, and what is extra virgin olive oil? The first point is that in the market you can find different typology of olive oil and different typology of extra virgin olive oil with a very large differences in terms of quality, because quality is very, very important, especially its quality inside to the face category that is extra virgin olive oil. Extra virgin olive oil is one of the category that are used for the international organization to commercialize olive oil. You can see the different opportunity. Extra virgin that should be the top quality, virgin olive oil and the olive oil. The first two are extracted only by a mechanical process without a chemical procedure. On the contrary, the last one, the olive oil, is a mixture between refined oil and extra virgin olive oil. Consequently, the most important differences is between the top extra virgin and olive oil. But inside to the extra virgin, we have a larger quantity of variability in terms of quality, because the quality is characterized by 3 or 4 different aspects. The legal quality that is related to the international standard used to classify olive oil, the safety related to the reduction of pesticide and the contamination in general, But the most important point, because olive oil are used in the world, is the health quality and also the sensory quality. And you can see also the sensory quality after our presentation during the testing. But it's very important to discuss about health quality. Why extra virgin olive oil is important for human health, and why we have different typology of extra virgin. The parameters that are used to define quality is oleic acid, mainly tocopherol and hydrophilic phenols, and in addition squalene and phytosterols. All these kind of products that you can find in extra virgin are bioactive, are able to transfer in the human body, go in the blood, and should be important for human health. The most concentrated bioactive compound is oleic acid. Oleic acid is the most important fatty acid that you can find in olive oil, but the range of variability in olive oil produced around the world of oleic acid is extremely large, between 47 until 84% of the overall fatty acid composition. When you're talking about biodiversity, this is one of the impact of the biodiversity. Because the concentration of olive oil is strongly related to the relationship between the environmental condition of production and the variety and the cultivar use. For this reason, it's very, very important to define as important parameter the concentration of oleic acid. In the Italian oil, when we're talking about high oleic concentration in olive oil, we can consider that the limit is 70%. The oil that are more of 70% are considered high level of oleic acid. The oil that is lower of this level is considered a low level of oleic acid. And Italian oil is all the oil at high level of oleic acid. Spanish oil is high level of oleic acid. Greek oil too. On the contrary, if you consider Tunisian oil is a low level of oleic acid, but also the oil produced in other continents. For example, Argentinian oil, the level of oleic acid is extremely low. And this is important for the health point of view, but also for the oil stability, because the rancidity is affected by the composition of oleic acid. High level of oleic acid, high level of stability. Another important point is the concentration of bioactive phenols inside the two extra virgin olive oil. We have two typologies of bioactive phenols, tocopherols. In this case, the most important compound is the vitamin A, and the vitamin A range inside an extra virgin olive oil between 50 milligram until 500 milligram per kilogram. As consequent, you must consider that inside to the same extra virgin olive oil class, you can find the oil that is like Ferrari and the oil that is like another mark, another company that is Ferrari is not Ferrari. And this is due to the mainly also this aspect is related to the biodiversity, but also other characteristics. Another important point is related to the phenolic compound. When we're talking about phenols are is a very large number of different compounds that you can find in all different vegetables. All the vegetables consumed by human contain phenols, but there is a very big differences between the phenols that you can find in the wine, or in the juice fruit, on vegetable, and the phenols that you can find in extra virgin olive oil, because the phenols that are found in extra virgin olive oil are bioactive, can be absorbed by the human body. This is very, very important. And the phenols are very, very important for the stability of oil, for the human health, because the most important aspects are related to the prevention of cardiovascular disease, cancer prevention, because they are compounds that are antioxidant and anti-inflammatory activity. Is very, very important, this kind of activity for human health. And the last point is the sensory attribute of extra virgin olive oil, because the extra virgin olive oil rich in phenolic compound, bioactive phenols, are pungent and bitter, are not sweet. This is very important for the consumer, because when you test an oil that is pungent and bitter, is an indirect characteristic that inform the consumer that this kind of oil is very rich in bioactive phenols and is very good for health. Another important point for the sensory characteristic are related to the volatile compound responsible for the flavor. This kind of compound that give a different typology of sensation, floral, herbs, cut grass, are produced during the process, the extraction process, and you can see after with the Professor Esposto the effect of agronomic and technological variability in the sensory and health characteristic of extra virgin olive oil. Thank you.
Questo è giusto? This one? Okay. Good morning, everyone, and I would like to thank you, Professor Mossa, for your presentation and for the organization of the entire workshop. And thank you, Professor Servilli, for giving me the floor. I would like to thank to our university, because it gives us the possibility to participate to this workshop. So, as well introduced by Professor Servilli, I'm sorry. The chemical composition of, I'm sorry, this is the right, okay. Chemical composition of the extra virgin olive oil plays a fundamental role in defining the oil classification, the sensory characteristics, and health promoting effects of the product. However, this composition is not fixed, because it depends on several aspects, which can group into 4 different factors: genetic, environmental, agronomical, technological. So we had the possibility over the last 20 years to analyze a large number of samples, and we can absolutely conclude that a clear effect of this variability is in oleic acid percentage, as you can see. In fact, we analyzed many samples obtained under different conditions, as well as coming from several parts of oil-producing areas. And particularly important is the effect of the olive variety. Today we talk about the biodiversity, and you can see the fatty acid composition, which can vary according to the olive variety. We choose some Italian varieties for giving an idea of this variability. The same trend appears in alpha-tocopherol. This is a very important compound according to its vitamin E and antioxidant activity, can range widely, and even in that case, a great effect is given by the olive variety. When it comes to hydrophilic phenols, European derivatives in particular, we can confirm this effect, or even better, the effect of different conditions in determining this very huge variability in concentration. For having a better idea, I would like to show you, for instance, the high concentration in European derivatives, in particular of Coratina cultivar, rather than the other variety. Coratina cultivar is a typical cultivar from south of Italy. It's very rich in phenols, and this concentration is absolutely evident. Same trend, same applies when we evaluated the volatile compounds. As Servili told you, Professor Servili told you, these compounds are important because of their correlation with those positive sensory notes, just like fruity and fresh notes. And we could observe that they can vary widely according to several conditions, but the olive variety has an important effect, such as you can see here, and this effect is so important, so high, that these compounds can be also used as markers of the genetic origin of the extra virgin olive oil. Well, in this regard, I would like to underline that biodiversity probably plays the most important effect in defining the quality of an extra virgin olive oil. You have to think that in Italy alone we have more than 500 different varieties officially registered, and this is absolutely the reason of our variability in our extra virgin olive oils. However, even if the biodiversity gives the extra virgin olive oil a chemical fingerprint, also the mechanical extraction process can influence the quality of the product. For instance, I would like to show you the main phases of the process. First, we have the crushing, and we have not only the breaking of the olives during this phase, but also the production of a water oil emulsion and the activation of several enzymes. Some of these enzymes are positive because, for instance, lipoxygenases, which is activated during this phase, is responsible for the production of those pleasant aroma of the extra virgin olive oil, thanks to the lipoxygenase pathway. Furthermore, we have also the activation of hydrolytic enzymes, which are responsible for the transformation of complex structure of the saccharidoids in the olives to simpler forms, which have a higher affinity to the oil. Furthermore, or even better, however, we have also the activation of negative enzymes in this phase. They are named polyphenol oxidases and peroxidases, and they are responsible in peculiar condition of temperature and oxygen concentration of the loss of phenols, those important compounds, because of their effect, their sensory and health promoting effects. The activation of these enzymes, so it can be considered absolutely negative. The next phase is represented by the malaxation, where a slow mixing of the crushed parts, the past occurs, and I'm sorry. Also, the coalescence phenomenon occurs. This is very important because it allows to recover the oil during the last phase. However, this phase is considered a critical point of the process because of the potential loss of phenols from these enzymes, those enzymes that during crushing are activated, and the potential loss of volatile compounds in the air. During the last phase, which currently is represented by the centrifugation, we have the separation of the oil from the wastes, which are olive meal wastes and pomaces, but also a potential further loss of phenols because of their high affinity to the water. Well, to address these challenges, many efforts have been already done to improve the mechanical extraction process. Thanks to this technological innovation, nowadays a modern olive meal producer can control all the phases and limit the negative effect of the mechanical extraction process in general. For instance, during crushing, we can reduce the release of those negative enzymes responsible for the phenolic oxidation by using stoner, teeth and blade crusher, and slow crusher. At the same time, we have nowadays the possibility to lower down the temperature of the olive pastes, which is an actual problem because of the global warming as well as the early harvesting, which is a very typical habit of our country. For this purpose, we can, for instance, use thermal exchangers as well as cooling crusher. During malaxation, currently we have the possibility to use a closed malaxer, which allows to control not only temperature and time, but also the oxygen concentration. Thus, we can limit the damage, the loss of phenolic compounds, volatile compounds. Lastly, we have also very new machines for the centrifugation phase, which led to separate the oil from the wastes, even if no water is added. So we can limit the loss of phenols in this phase. Well, I have to go forward. I would like to underline also the importance of the post-extraction process phases, just like filtration, packaging, and storage condition. For instance, I would like to show you a very recent research that allowed us to demonstrate that oil stored in high light-resistant and oxygen barrier packaging maintaining higher and longer their quality. Furthermore, we also could observe that the higher the initial concentration of those compounds which have a higher antioxidant activity, just like European derivatives, the longer the life of the relative product, both in darkness or under light condition. Just for concluding, I would like to underline also our participation to a very important European project named Olium, which had several, key goals. One of them was to define a proper, a reliable method for determining a proper best before date of the extra virgin olive oil according to its initial chemical composition. For doing that, we analyzed a large number of samples that gave us the possibility to build a data set which now feed into a software tool. And this software tool can be used by producers as well as by regulators for determining a proper before date, expiry date according to the initial composition as well as peculiar conditions of storage. Thank you very much for your kind attention. I would like to give the floor to my colleague Agnese Taticchi.
Thank you very much, Sonia. Just to complete our presentation about the importance of extra virgin olive oil also in contributing to the current need to improve sustainability in agri-food value chain, it is important to remark that it is important also in the process to find solution to improve sustainability, and the right approach will be to give and recognize the right value to each product coming from the process. Actually, the value chain of extra virgin olive oil is not a good example in this point of view, because currently the situation is that only the oil is the effective product, and it represents normally between 10 and 20% of the coming product, whilst the remaining part of the olive fruit that is the effort for which olive growers work on, is represented by wastes. Wastes are named pomace, that is the solid waste, and olive mill wastewater, that is the liquid waste. They are a problem because they have to dispose it of according to local and national regulations, and the current situation is that relatively just for the pomace, there is an alternative use to that, that is the traditional one, spreading off on the agricultural soil. For the pomace, actually currently there is also a good involvement in the production of biogas and the use of the pomace as fuel, but for olive mill wastewater, the real disposal method is currently still the surface spreading on the agricultural soils, giving some concerns about environmental alteration of soil and phytotoxicity and groundwater pollution also. The reason of the polluting load recognized to these wastes, both pomace and olive mill wastewaters, is mainly in their very high richness in olive phenols that are on one hand very precious and worth value compounds for a unhealthy and quality point of view, but they are also very polluting because they show strong antimicrobial activity, and so for this reason the current bioremediation strategy doesn't work because they are antimicrobial. But giving importance to the dual properties of phenols, antimicrobial, polluting, and biological properties, our approach in the last 15 years of research was to try to develop a new method to have two effects. The first is the reduction of the polluting load of the olive mill wastewater, and the second one is the recovering of these precious compounds. We developed for this objective a new method for the treatment of olive vegetation water, giving also the possibility to almost completely depolluting the load, the depolluting load of the vegetation waters that can be normally disposed also in the same extraction process. They can be recycled. And on the other hand, we can recover a phenolic concentrate that represents a new product. This new product can be, according to our results, also further stabilized and formulated as a new ingredient in different formulation, in powders and in liquid form, with ranging concentration between 45 milligram per gram up to 700 and more milligram per gram of phenolic compounds that are very bioactive thanks to the green approach adopted in their recovering. This ingredient is something that the food industry is looking for as a special ingredient that can be used in food production, and it is perfect from several points of view because it is effective for its antioxidant power and antimicrobial power, and it is also a natural compound coming from a circular economy approach. I have not time to show you all the results we obtained in several applications in food products, testing their efficacy in fortified new products, or also as a natural additive, a natural preservative that can be added in several food matrices, in refined oil to increase stability, and to increase also the nutritional value of all the products that can be cooked with. And in some more complex formulations, like mayonnaise, as you can see, and also in processed meat. We obtained some very encouraging results that now are driving our way to dispose olive meal wastewater in another approach, because they can really can be considered not anymore a waste, but now they can consider a co-product that also contributes to a fair profit for the olive oil value chain, and then the division can be can address with some very good result toward more better sustainability. Thank you very much.
Okay, so good morning, everybody. Konnichiwa. So let's have to make a step backward to the field, to the tree. In Italy, we have some points of weakness. So you can have an idea here about the distribution of the olive tree and the olive surfaces in Italy. But the point of weakness is that we have the 62% of the surfaces that are in hilly areas, and we have usually a small area for each farm. Which are the point of strength? We are here to speak about biodiversity, and this is our strength. So we have a very, very high number of olive cultivars. Here in this table, you can have an idea about some of these cultivars spread in the different regions, and you can have an idea about the destination of the product. So the production of olive oil, the production of table olives, or double aptitude. So we may use some cultivars to produce olive and table olives, olive oil and table olives. Here is our region, Marche region. It is a small region in terms of oil and table olives production, but it is still interesting and important region because of a quite high number of local cultivars. You can have an idea here about 22 local cultivars, and usually these cultivars are located in very, very specific areas. Thus, the name of the cultivar is the name of the village this cultivar is managed, is cultivated. Just to give you some ideas, this is the queen cultivar for our region. This is called Ascolana tenera. Ascoli Piceno is the name of the town. And this is double aptitude cultivar, so you can have an idea on the right about the spider net, so which are the specific sensory characteristic of the oil, tomato sensation. But this cultivar is very, very famous for the production of table olives that are stuffed with meat, and they are fried, very, very tasty. Of course, we have very important olive trees for this cultivar. This is in particular, the estimated age is 800 years. So we have many, many of these trees spread all over the countryside, but many of these trees are also located inside the town, so in the urban area. Here, just an idea about Ascoli Piceno. So we have more or less 1,000 olive trees inside the town, and 100 of these trees are from Ascolana tenera. And here we, just a study case, we went to have a census of these trees, and just to characterize them. It's very, very interesting. This is another cultivar. It is called Coroncina. It is spread in Macerata area, province, and is characterized for an artichoke sensory characteristic. This is Mignola, another very, very interesting cultivar. The sensory characteristics is for berries. And we may have these huge, big, ancient trees all over the countryside, but again, we found these trees, for example, inside our hometown, Ancona, and we had this interesting case study as a participatory recovery management for ancient urban olive trees. Collaborating, for example, with a high school just to recover these trees and to use as a community a positive characteristic. Which kind of olive orchard we have in Italy? We may have very traditional olive orchards with huge trees. In this case, we need to recover them because they have an interesting multifunctional activity, multifunctional purpose inside the farm. And in this case, you can see, for example, we have mixed cropped with grape, for example, or other crops. But we also have semi and intensive specialized olive system, going from single trees to hedgerow olive orchards. Why we need to increase the specialization of these olive orchards? Because we need to speed harvest, so we need to introduce some mechanical systems to speed harvest because of a lack of labor to manage some practices. So for example, on your right hand, you can see this over-the-row harvester. It's a continuous system, so the harvest is very, very, very quick. But of course, going to toward an intensification of the olive orchard, we have to face some problems, physiological problems. For example, the high transmigration ability of the root system of the olive. Of course, this is not a problem when we are working with low-density olive orchards, but when we are going to toward hedgerow systems, we have to manage this situation. So the transmigration is contrasted by the reductive distance between the trees. So we have to know how to manage this situation. Of course, even the canopy architecture, the canopy management, it is very simple. So we can manage the different vigor and habit of the cultivars, managing the intensity or the turn of pruning. But of course, when we go toward this system, very intense system, we need to have very, very important characteristics for the cultivar, so the distribution of the primary branches, the conical shape, and so on. So we can have some different groups of varieties that are suitable for the high density and to the intensification, not only in the canopy, but even in the branch dimension and in the branch distribution of the ramification. Of course, it is very important to not forget to maintain a strong biodiversity in the field. So we have to work between the rows maintaining a high biodiversity through a green cover that can be managed with periodical mowing or using these flattening systems, or to have this minimum tillage along the row, or, for example, introducing some living mulch, so some new biodiversity below or along the row. Okay, thank you very much, and I leave the floor to Davide.
Thank you. Now we are to introduce technology to manage biodiversity. And so what we can do, we can use the observation by distal approach or by proximal sensors. And so we can go in direction towards the possibility to use the satellites, the distal sensors like drones, and to use the proximal sensors. So to touch the tree and try to ask to the tree what is the meaning of what we are doing, and it can speak with us. So first of all, the monitoring of the environment, or the kind of information about the humidity, the temperature, are very, very, very important in the air, in the soil. And then to have this information on our tablet, on our phone, to have the possibility to control directly. And you can see here what the sensor can show us, the humidity in the soil that is changing in the top part, in the below part, and then we know where are the roots, and we can say, okay, what we can do, make irrigation or make some operation with the weeds. So when you have this kind of opportunity, you can describe your orchards, your growth, and you can see the big differences also in the impact of this condition, mainly in the soil, on the diseases and the pest diffusion inside the orchard. And here you can see an example of one increasing pest that is Phytophthora, so pathogens. Here, some systems that make us available the possibility to have the information about the pest. In this case is a fly that is very dangerous for olives, and again we have information on our cell phone. We have seen the architecture of the tree. Now we can describe the architecture of the trees using some systems like LiDAR, so laser system, or just our camera in the pocket can be used. So we have some simple system to describe the trees and to have the information about the skeleton, about the leaves, about the fact that the leaves are too crowded, and so we have to prune. We have to make the training system more open to get some results. So we have all the possibility now to have our orchard in our pocket and get the information to make the evolution. So in this case, precision pruning systems that can describe the tree, or even in this case, you have the possibility to describe the skeleton using some RGB sensors. In this case, we have a system on a tractor that is going on the orchard and get all the information and make possible the precise activity on the canopy. And so we can have the map of our orchard and see how is big the trees, where we have to go to prune as much is possible, mechanically reducing the use of labor. That is a big problem for Italy at the moment. Then proximal sensors. That is an experiment that was carried on inside the Vitality project. And it's very interesting because you can have the gauge on the fruit, and you have the information about the fruit growth during its life, but also during the day, hour by hour. So we can see that the fruit during the day is shrinking, and in the night is enlarging. And every day is doing this way, and every day is growing. So you have the description in this way that is three-dimensional, because you have the growth every day and along the period in which the fruit is growing. So you can see where is the fruit is ready to ripen, and with some characteristic that we have seen very important to give the quality of the extra virgin olive oil. I go to finish. So we can put on this growth curve the activity to control the growth and to get the value. We have put some local variety. You see Piantone di Falerone, Ascolana Dura, and Lea, and the one that is becoming more and more popular, that is Arbequina. But Arbequina is a local variety of Spain. So it's something just we are trying to mix to get the result for our country. In this case, we have the possibility to put the gauge on the fruits, on the shoots, on the branch, trunk, and roots. So you can describe how is going all the water inside the tree up to the leaves and up to the fruit, and so you have the possibility to better control everything. Just to finish, this is a part of the work that was done with the Omibred, another project. You can see a very ancient tree, this giant of Aliste, il gigante di Aliste, che è morto. It's dead because of Xylella fastidiosa, because of the bacteria. That was terrible. But you can see around new growing olives that are from germplasm. So that are some olives varieties that are tolerant to this disease, and so we will have extra virgin olive oil for the future, starting from our past. Thank you. And thank you for the projects that were involved in our financing support.
Thank you very much for the presenters of this session. It was very interesting, and now we can't wait to have the olive oil tasting later. So thank you very much. Now we have a session about minor cereals and legumes, and linked also to the rural society and local traditions, so also this presentation will be very interesting. So I'm going to invite Giampiero Sacchetti from the University of Teramo and Giovanni Caprioli from the University of Camerino.
Good morning, everybody. I want to thank the organization of Bionet for inviting me here today. And I'm going to speak of minor cereals. And what we are talking about when we talk about minor cereals. Minor cereals are a group of cereals crops less commonly grown and consumed than cereals like wheat, rice, and corn. They are often cultivated in challenging environments and marginal lands. Nowadays, within the group of minor cereals are also considered heritage wheats. Heritage wheats are ancient or old cultivars or land races of Halles wheat that were not subjected to breeding or modification programs. And this variety maintain the characters of their wild ancestors. This is a genealogic tree of wheat Italian cultivars, and among the oldest Italian cultivar we can find Solina. Solina is a old cultivar that is nowadays cultivated in the Abruzzo region, in the mountain area of the Abruzzo region. How old is Solina? In order to understand the ancientness of a grain, the first thing is to try to find historical documents. And Solina dates back at least to the 16th century. and a sale document at the fair of Lanciano mentioned Solina as a variety. In the 18th century, Solina was considered as one of the best bred wheat variety in all the range of Naples. In our group, we proceed to the identification of Solina genome. The DNA of Solina was sequenced through whole genome mapping techniques. And the DNA of Solina was compared with those of all the world cultivars and land races that were surveyed by CIMMYT. The result is this dendrogram, and we can understand from this dendrogram that Solina has no Italian parentals. But if we can see the nearest neighbors of Solina, they were land races from the Fertile Crescents, Turkey, Iraq, and Iran. So this means that Solina probably comes from an area in which wheat was differentiated at least 10,000 years ago. We want to go through this work and try to find a place of Solina in the worldwide wheat biodiversity contest. So we mapped the DNA of 24 Solina accessions that were collected all through the Abruzzo region. And in this graph, there is a geometrical representation of Solina world wheat varieties. And the outer green ellipsoid represents the genetic diversity of all the world land races. The inner red ellipsoid represents the genetic diversity of all the world cultivars, and the blue ellipsoid represents the diversity of Solina. So Solina takes a large part of the world biodiversity. This means that it's not a variety, but is considered a population of wheat. These results confirm the result of a previous studies which showed how the biodiversity of Solina was much larger than the biodiversity of many other European land races. By exploring Solina biodiversity, we understood that there were two main groups of Solina, two main clusters of Solina. And these two genetic clusters were traced back in their natural environment. We can see that the larger cluster, that is a blue clusters, come from samples of Solina that were collected in a large area within the Aquila and Pescara province, whilst the smaller cluster, the red cluster, comes from an area that's situated in the southeast of the Abruzzo region and is a mountain area. The mean altitude of the blue area is 500 meters above sea level. The altitude of the red area is above 800 meters above sea level. The two clusters are different for selected genes, but very important are genes that are involved in vernalization and photoperiod. So the first cluster that was collected at the 500 meter above sea level does not require vernalization and has a shorter photoperiod. While the second cluster that was collected in mountain area requires vernalization and has a longer photoperiod. So we drove the conclusion that long-term in situ conservation drove a microevolution of Solina toward adaptive traits. The adaptation to the territory of Solina, the adaptation to the altitude of Solina, permits to give high yield in agriculture that is carried out in hills or mountain area. So Solina in this condition could perform better than modern varieties. And moreover, the protein content of Solina is not different from that of modern varieties. Another important thing is the adaptation of Solina to the territory permits to this grain to synthesize a lot of volatile organic compounds. We all know that all plants synthesize volatile organic compounds in response to biotic and abiotic stress, like, for example, mountain cultivation. And in response to cultivation in high altitudes, Solina can produce much more volatile organic compounds than modern wheat. And most of these volatile organic compounds are flavor active, and they have a lot of different flavor notes. A question remains if Solina has a distinctive flavor compared to modern wheat. The response is yes. It was possible to differentiate the volatile organic profile of Solina from those of modern wheat varieties. And it was possible to understand that Solina has distinctive notes that goes from bread crust to floury, woody, and fennel. Another question is if the flavor compounds of the wheat could be transferred from wheat-based product. And in this case, we tried to trace Solina flavor from wheat to wheat beer, for example. And the first graph represents a consensus map by shape analysis in which we found a consensus between the volatile organic profiles of Solina and those of Solina-made wheat beer. And by using the first dimension of the Procustes graph, we were able to differentiate the profile, the volatile profile of both Solina and Solina wheat from that of another variety, from common wheat variety, at any altitude of cultivation. Oops. And we went through chemical analysis and tried to find if instrumental and sensory analysis, it was possible to find a consensus between instrumental and sensory analysis. And also in this case, it was possible to differentiate Solina wheat beer from wheat beer that were produced using Vittorio at different altitude of cultivation. While talking about Solina wheat kernels, we have to remind that Solina is a soft wheat, softer than modern variety, but has a peculiar characteristic that upon milling, it shows a higher particle size than modern wheat. And this determines a particular characteristic so that Solina has a low water absorption. As far as bread making quality is concerned, the Solina wheat has a low gluten strength, so lower strength than modern variety, but on the other side, it has a lower tenacity and a much lower extensibility. And it is this very high extensibility that grants Solina a good technological performance. In terms of bread volume, if we are talking about refined flour, Solina can give the same results that modern variety. When we are talking about whole meal flour, Solina gives results that are yes, sufficient, but not optimal. We wanted also to understand if it was possible to exploit Solina flour in order to make tailor-made food products. And we have to remind that Solina flour has a distinctive flavor, low hydration capacity, and low gluten strength. So we deduced that the best type of food product for this characteristic were dried bakery product. We choose breadsticks as the target product to test Solina. And why breadsticks? Because they have low moisture, so low hydration capacity is good for this product. They have limited leavening and brittle texture, so low gluten strength is not a problem for this product. And then breadsticks are often used as appetizer, and so the distinctive flavor of Solina could be a good choice for this product. We used 9 recipes by adopting a central composite experimental design to make these breadsticks, and we used also 5 different mixing processes in order to have 14 samples, and we prepared these samples and we subjected this sample to sensory analysis. All the panelists were able to appreciate that Solina breadstick, all the Solina breadsticks have higher friability than the control samples that were modern with variety. And also, as far as flavor is concerned, all the Solina samples, they have higher wheat flavor than the common wheat. Take-home messages. Heritage wheat represents an extraordinary resource of biodiversity. Solina is an ancient wheat that is well adapted to mountain area with a distinctive flavor and providing interesting yields in this condition. For this reason, it has been cultivated for centuries and became a part of the Abruzzo tradition. Research aimed to study heritage wheat could help to obtain high-quality foods by adding value both to the food products but also to the territory of production. Heritage wheat for sure will not feed the world, but can enrich agricultural system, bringing back diversity to the field, and hopefully also to the dishes. And they open new perspective for those who, in the heart of the mountains, wants to build a different future. Thank you for your attention.
Good morning, ladies and gentlemen. I'm Giovanni Caprioli from University of Camerino. And today I would like to talk to you about two research lines that we have in our university. The first one is about the nutraceutical potential of legumes or pulses. And the second one is about a forgotten fruit that is a corn, and especially a corn flour. 20 years ago, we started to work on legumes with Professor Sagradini that is here, and we were seeing into legumes because they have an excellent nutritional profile. They are rich in polysaccharides, in dietary fibers, minerals, and vitamins. And it's well known that the inclusion of legumes in the daily diet has many beneficial effects in controlling and preventing various chronic metabolic diseases, such as diabetes mellitus and coronary heart disease. At the time, we focused partially on nutrients. I will show you some results about the fat and fatty acid profile. But we focus mostly in two classes of compounds, on bioactive compounds, in particular saponin, especially soya saponins, and polyphenolic compounds. Why? Because legumes are primary dietary source of soya saponins that display, in particular, soya saponin 1 and soya saponin 6 that are present in huge amount in legumes. And they have many biological effects. In particular, they can lower plasma cholesterol level by different mechanisms. And in our research group, we investigate, so we found the actual mechanism of action of reduction of cholesterol. That is the second mechanism is the indirect one by inhibiting the reabsorption of bile acids. So we started to screen a huge number of legumes coming from our region, from, in particular from the Umbrian, Marquesian Apennines. You can see here the Castelluccio di Norcia. We screen this kind of molecules in lentil from Colfiorido, in lentil from Castelluccio di Norcia that received the IGP indication from European Union. And then we do this kind of analysis of other legumes, in particular lentils from Pievetorina, from Visso, but also from other regions of Italy, Sicily, Puglia, because these legumes are cultivated in most of Italian region. So before we started to quantify soya saponin 1 and soya saponin 6 in different legume samples, and we found that these compounds are present in high amount in soybean, peas, chickpeas, and also lentils. This data is related to raw legumes. But we perform the same analysis also in cooked legumes. Cooking procedure can affect the level of these bioactive compounds. Sometimes can reduce this bioactive compound, sometimes can increase the amount of bioactive compound. In this case, the level of soya saponin of these cholesterol-lowering compounds does not change from raw legumes to cooked legumes from most of legumes except for peas, in which there is a reduction of soya saponin after cooking. After that, we evaluate, in collaboration with the University of Valencia, the bioaccessibility of this compound, so the amount of soya saponin that can reach the stomach, the intestine, and so on. So we cook the legumes, in particular lentil, and we simulate the digestion. We put this sample in contact with the simulated saliva, with we simulate the gastrointestinal digestion, and we assess that not only the content of soya saponin does not change after cooking, but a conspicuous amount of soya saponin reach the duodenum, and over there can lower blood cholesterol level. We have a bioaccessibility of 10%. That is not a low amount, considering the high concentration of these compounds present in legumes. After that, we focus our attention on a second class of bioactive compounds, in particular phenolic compounds, that are interesting molecules because they display many health-promoting properties, such as they have antioxidant activity, anti-inflammatory activity, antimicrobial activity, and so on. And in particular, we focus our attention on the relationship between the color of pulses and the level of polyphenolic compound. And we assess in a paper that we published in Food Chemistry that the dark color, black, dark purple of legumes is associated with a high amount of polyphenols. Instead, black legumes, black beans, black lentils, black chickpeas are associated with a high level of anthocyanins that display different biological activity. Instead, red legumes, like red lentils, red beans, and so on, they are associated with high level of flavonols, such as catechin, epicatechin, and flavonols, such as rutins. And we know that the benefit of flavonoids are associated with endothelial function, and in particular, reduction of cardiovascular and disease. After that, we were thinking to lentils as a nutraceuticals. So we study the lentil extract on rats. We perform an in vivo study on rats, and we assess that this lentil extract that is rich in soya-saponin and in polyphenolic compound significantly reduce cholesterol, total cholesterol of 17%, with a reduction of LDL and increasing of HDL. After that, in collaboration with the pharmaceutical technologists of our university, we also obtain a capsule. And this activity, we have a patent, an international patent, the PCT patent on it, with Professor Sagratini, Sauro Vittori, myself, and other colleagues of my university. After that, I told you that we partially study also lipids, and in particular fatty acid, and we screen the fatty acid profile on 40 legume samples. And in particular, the level of lentil are particularly interesting because they display high level of PUFA at 25–28% of MUFA, especially oleic acid, and a low level of saturated fatty acid. We are happy of our results because since many years, the Food Agricultural Organization use this data. These data are present in the FAO in food composition database. These are some of the publications of the article that we publish in most high impact factor journal like Food Chemistry, Journal of Agricultural and Food Chemistry. After that, since a few years, we started a research line on acorn flour. Acorn flour is particularly interesting because it's, first of all, it's gluten-free. It's naturally gluten-free and presents an interesting nutritional profile because it's rich in polysaccharides, dietary fibers, minerals, vitamins, such as vitamin A, vitamin E, and polyphenolic compound. This work, I'm the PI of a this one is one of the two PRIM projects that I got 2 years ago. It's called Acorn, so it's financed by European Union, Next Generation EU. There is University of Camerino, PI, University of Parma, University of Milan. And we are studying not only the nutritional composition of acorn flour, but we are also formulating some product like brew, porridge, bread, pasta, snack, enriched with acorn flour. And we are also performing some study on an in vivo model of testing the effect on Alzheimer's disease in an in vivo model of Drosophila melanogaster. So I will spend just a few words about this work that mostly now we chemically characterize acorn flour, and we discovered that it contains a lower protein with respect to wheat flour that my colleague was speaking before. They have a higher content of fat with respect to wheat. We are around 6, 8, 11%. It's different according to the harvesting times. And they display a high level of minerals, in particular calcium and potassium, and are rich in monounsaturated fatty acid that are the prevalent fatty acid. So in particular, as you can see here, oleic acid, and then a noteworthy level of polyunsaturated fatty acid. We perform also the chemical characterization in terms of polyphenolic compounds, and we assess that acorn flour is particularly rich in two polyphenols like gallic acid and ellagic acid, so here, that are associated with different health-promoting properties. And acorn flour has a particular smell, a particular taste. The volatile profile of acorn flour is particularly interesting as it is quite rich in acetoin, that display a pleasant battery odor, but also estragol that has an anistic type odor, and also, of course, other volatile compounds that are quite peculiar. We perform some study, not only on the chemical point of view, but we test also the biological potential of acorn flour extract. In particular, we evaluate the enzyme inhibitory activity against different enzymes like acetylcholinesterase, butyrylcholinesterase, lipase, amylase. So this extract have great biological potential. These tests are in vitro tests that might be predictable of some important disease like diabetes, like Alzheimer, Parkinson, and so on. And we also published some data about bread enriched with acorn flour that is interesting from a technological point of view, but also from a health perspective. So after that, we are in Japan, we are in Expo, and I would like to spend really 1 minute about the activity we are carrying out between the University of Camerino and an important university in Japan. Last year we presented an Erasmus project, and it's called KA171, and it's a project with University of Camerino and different universities all over the world, the top university in the world, like some university in USA and Canada. And in Japan, we have this strong collaboration with the Ritsumeikan University that has campus in Kyoto, but also in Osaka. It's the private university #1 in Japan. And with that, we are exchanging students, staff, and so on. And the mobility will allow the participation of professor and teacher in Italy during a big festival that is carrying out in March in our region in Fermo, that is Tipicità. And Italian professor, we have the opportunity to come again in Expo and to do activity in collaboration with Ritsumeikan University. Then I will show you also some picture about this mobility. And of course, this mobility will be also fruitful in terms of scientific publication. There will be the first student from Japan will come to our laboratory in September, and he will start to work on acorn flour, because also Professor Masayoshi Ishida from Ritsumeikan University is interested in acorn flour. And then we will come back in Japan in the next months here in Expo and at Ritsumeikan University in Kyoto. These are one of the activities, the first mobility. Professor Masayoshi Ishida came to University of Camerino last March. So here it's the day with our rector, our vice rector. And then together, me, Masayoshi Ishida, and Professor Sagradini, we were involved in different seminar and activity in Tipicità. We were involved in seminar in dealing with the Japanese fusion cuisine, and in other seminar in which we talk about our typical food of our region in Tipicità. And here is my visit last November in Ritsumeikan University, and with the Ambassador Battani and the Italian embassy in Kyoto. So other mobility, so it is not my second time in Japan, so I'm sure that I will have the opportunity to visit your wonderful country again, because it's a really lovely country. So thank you, all of you, for the attention, and especially the Japanese audience. Thanks.
Thank you very much for your valuable presentation. This was the presentation from Giampiero Sacchetti from the University of Teramo and Giovanni Caprioli from the University of Camerino. Thank you so much. And now we are going to invite Antonella Micucci from the University of Urbino and Maria Benedetta Mattei from the University of L'Aquila for their session about truffles and mushrooms. I'm quite sure that since we are approaching lunch time, your presentation will be very much stimulating in all senses. So, please, Antonella.
Thank you very much. Good morning to everyone. It's a great pleasure to be here in Osaka, and it's also a great honor to introducing you our guest, illustrious guest, the truffle. And we are going to explore the fascinating relationship between the scientific research and the truffle, and our research can help preserving this huge heritage. It has a long time that it is studied everywhere. Of course, Plinius the Elder was probably the first one that defined it as among those things that are born but cannot be sown. Unfortunately, it is not like this, because truffle itself, the fruit body, the fungus that we know, really actually is the reproductive organ of a nectomycorrhizal fungus that lives underground. In fact, this reproductive organ contains spores that, when it decomposes, germinate in the soil, forming a very complex hyphal network, and this is the longest phase of its life cycle. When hyphae of opposite sex in the soil meet, recognize themselves, and merge, another kind of hypha give rise, and this type of hypha can recognize the host plant roots, establish a mutualistic symbiosis with the plant. After that, a new kind of hypha develops and make possible the formation of the fruit body, as we know. But many biotic and abiotic factors can strongly affect the accomplishment of this cycle. In fact, the host plant root, microorganisms, macrophages that feed on them and helps the dispersion of spores. And among the abiotic factors, light, gravity, temperature, increasing temperature is a big problem, and of course, soil type and nutrients. So there are, of course, many problems to be faced, and research can help in this. Tuber magnatum, that is well known as the most, not only famous, but really appreciated truffle, is widespread all along the Italian Apennine ridge, up to Basilicata, certain areas of Sicily, Istria, and other areas not well officially mapped in Eastern Europe, while Tuber melanosporum has a more limited but broader habitat, and it is easier cultivated, while for Tuber magnatum cultivation there are still some difficulties. Of course, we all know the many facets of truffle's value. They have a great economic impact because of the commercialization, and they improve the gastronomic tourism, and the forest with truffles is a healthy forest, and it's important for the conservation of the biodiversity. But there are some difficulties sometimes, and here I summarize some of them, some critical issues that we can identify. The first one is the species identification that is important for commercial fruits and for all the experiments that we can do in the lab. The other one is the decline in production due to anthropization, to the increase in temperatures. And the last, not the least, the post-harvest valuation of truffle, because the not good quality of truffle, of course, can compromise the commercialization. So Urbino and L'Aquila University, together with also other research groups all over the world, have been studying for more than 30 years, trying to answer to these issues. So I'll try to show you some of the most important researches that gave some new, how can I say, application tools to answer to these problems. The first one regards the identification. Traditionally, the truffles are identified by expert mycologists through the microscopic analysis of spores, of ectomycorrhizae, but the peculiar and specific features may be lost. For example, in unripe fruit body, the spores are absent. So in the example here, to go back, the pointer is this. This is a fruit body of tuber magnatum. When it is unripe, it is similar to Coiromyces meandriformis, that is a truffle collected in North Africa, not prized at all. So going on, there are many examples where this is the problem. That's why Urbino, L'Aquila, and other researchers decided to study the DNA, and we, together with the other researchers, defined many DNA-based techniques, PCR, to identify most of the commercialized truffles. Here are summarized in a recent review. And these techniques can be applied to control the fruit bodies commercialized, the mycorrhizal seedlings, and all the experimentations in the field and in vitro. And of course, they are applied also in truffle-based food products, where the cooking, the high temperature destroy and change the morphology of the spores. Another aspect of the research that recorded, at least in these results, Urbino, is about aromas. Of course, the aromatic buffet, the buffet, I'm thinking about the buffet later. The aromatic bouquet is one of the main characteristics that make it so appreciated. But aromas are not produced only, or at least not only for human enjoyment. They have an important biological role. In particular, they are a sort of communication tool with which they speak with the plant, with the microorganism present in the soil. They are attractants for small animals that feed on them and disperse the spores. And also the two hyphae of opposite sex that have to meet, they recognize themselves and merge after a recognition through an exchange of these substances. And we apply the chromatographic tool to analyze different species, because the aromatic profile is distinctive, is different among the species. Then we applied it to discriminate inside the same species, so intraspecific variability, because the aromatic profile is affected by the soil, the pH of the soil, and so on. And we also analyzed the maturation, so we found ripening and conservation markers. Regarding the role of macrophages animals, I said that the aromas are attractants for them, but their role is not only the dispersion. In fact, we could see that the passage of spores inside the digestive system of little mammals, also big mammals, such wild bear, wild pig, thins the spore cell wall, as is visible through the analysis of atomic force microscopy. And this helps the germination. In other experiments, we could see that not only the thinning of the spore wall, but also a major ability of mycorrhization. In these experiments, we feed snails with truffle, with tuberostemum in particular. We could see that these spores, after the passage in the intestine of snail, helped mycorrhization. Another interesting aspect of our research regarded a third host of this symbiosis, the bacteria. In fact, a huge community of bacteria are present inside the fruit body, in the mycorrhizosphere, the soil surrounding the truffles, and in all phases of life cycle. And we know that they can affect the aroma, they can help plant growth, mycorrhization, germination. They can also protect against pathogens, and they have sometimes a nitrogen fixation activity. We found in tuber magnatum ascoma, Bradyrhizobium, and this nitrogen fixation activity attributed to Bradyrhizobium is very important because the nitrogen present in the soil is unavailable for the truffle and the plant. So this bacteria helps the plant and the truffle to use the nitrogen in the soil. And several Bradyrhizobia were also found in tuber magnatum mycelial cultures that cannot grow without this bacteria. So this will help us to obtain pure tuber magnatum mycelial cultures to get tuber magnatum mycorrhizal plantlets of high quality. Other bacteria were tested. This is a research that we performed with the University of Ancona, where Pseudomonas were used in mycorrhizal plants, and a positive effect was found in the degree of mycorrhization and also application in the field, and we could see a positive effect. Another aspect of the research regarded how can truffle face or resist to the increasing temperature. In fact, tuber magnatum and tuber melanosporum are highly sensitive to the increase of temperature. We studied another truffle because it's easier to have it in the lab, tuber borki, and several strains of tuber borki were grown at increasing temperature, and we could see that some of these strains were more resistant to the increase of temperature because they were able to switch on molecular mechanisms that make them able to resist, to go away far from the problem, to find water elsewhere. And this is important because, of course, if we have the characteristic of the soil, we can suggest the most suitable strain or species when someone wants to establish truffle cultivation. Another aspect was the heavy metal pollution. As we all know, the heavy metal pollution can destroy or decrease the biodiversity and, of course, also the food chain. Some fungi has the ability to sequester heavy metal from the soil. So we wanted to see if some truffles could have this ability. And also in this case, we analyzed several strains of tuber borki, mycelia, and we could see that some strains are able to sequester high concentration of lead from the soil, store it inside vacuoles in some cases, or store in form of crystals outside. at higher concentration. So using, of course, not priced truffles, because the heavy metal was not stored in the ascoma at all. So this could be an interesting sustainable macro-remediation strategy. Other interesting results were obtained recently by the L'Aquila Group, and regarding the problem of post-harvest monitoring of truffles, because we know sometimes where we buy the truffle, we cut it, and we see inside some worms or cavities that outside are not visible. And this is a problem because a huge community lives inside truffle, not only bacteria, but invertebrates and so on, that cause internal rottenness or cavities that compromise a lot the commerciability. And in L'Aquila Group, they optimize the quantitative magnetic resonance in order to visualize all this cavity without cutting the truffle at all. And with the same technique, they optimize a method to observe the freshness of sample, and this part means that the percentage of water was decreased, and the decay of truffle in the conservation period, and more challenging research, the identification without cutting at all the truffle. So the truffle can be identified as I said, looking at microscope or taking a little piece in PCR, but in this case, the truffle is absolutely intact. And the gleba, of course, is characteristic of the samples. At the end, I just want to cite very quickly the first genome sequence of truffles, the tuber melanosporum, that represent the importance of the omics techniques that open very new strategies. I'm just conclude saying that, of course, research is important not only to improve knowledge of the biology of this fungus, but also to answer to critical, specific critical issues that we hope can help in preserving the cultural, economical, and commercial value of truffle. I have to thank so many researchers that I decided to thank only my two young researchers that helped me in this period. So thank you very much, and I give the floor to Maria Maddalena.
Thank you very much for to the organizers and to Professor Amicucci for introducing some of the research that we are doing at the University of L'Aquila. So I will continue to guide you through an exciting journey in the exploration of biodiversity in fungi, especially those from extreme environments that require specific strategies for survival. So the more resilient species, they develop particular specific strategies that are linked to the production of secondary metabolites that can have very important roles in also in nutrition and human health. So I will explore a few projects. The first project is PRIN, funded by the Italian PNRR, the Next Generation EU plan. And it's tapping into the biological potential of wild mushrooms from a range of ecosystems in Sardinia and Abruzzi. So this is a cross-disciplinary project involving mycologists, biotechnologists, chemists, and health scientists. investigating microfungi from two different ecosystems, from the Mediterranean coastal areas in Sardinia and the mountain continental regions in Abruzzo. And the fungi that are adapted by the stress adaptation are potential reservoirs of many bioactive compounds that can have application in health, functional food, and therapeutics. So why fungi? Because they offer really an untapped potential of biodiversity. There are 146,000 more or less known species, but the more recent estimates predict that several millions may exist. And as I was saying, they are a reservoir of bioactive molecules, and in particular, stress-resistant fungi may offer, for example, antioxidants, anti-inflammatory agents that are very useful in preventive medicines. Also, they are a source of prebiotics that are especially beneficial for the gut microbiota and gut health. And then also tyrosinase inhibitors that are gaining a lot of interest in cosmeceuticals because of their skin brightening properties. Then there is an aspect of sustainability, because cultivation in controlled conditions can avoid over-harvesting and so preserve the biodiversity. And also the use of green extraction methods for the extraction of these bioactive compounds can decrease the footprint, the environmental footprint. So the project has a pipeline from the nature to the laboratory to the product. So the wild fungi are identified and selected. And then the conditions for their growth are optimized in laboratory. And then the metabolomics, advanced technologies are used to identify and characterize all the different bioactive molecules. And then the next step is the exploration of applications of these active molecules and the identification of potential markets for these products. Okay, then talking about bioactive molecules in fungi, then we ventured into the fascinating world of endocannabinoids, thanks especially to the work of Professor Mauro Maccarrone at the University of L'Aquila. The endocannabinoids are very often associated to the cannabis sativa and to the human nervous system, but in fact, these are some of the recent projects that have been funded by different funding agencies, all involving either the Ministry of Health and or the Ministry of Research and the PNRR. So endocannabinoids like anandamide and 2-arachidonoyl glycerol act by binding to several receptors, and the action of these endocannabinoids is controlled by a number of enzymes responsible for their synthesis, transport, and degradation. And together, all these receptors and enzymes form a complex network called the endocannabinoid system, or ECS. Recent evidence show a role of the endocannabinoid system in regulating appetite, food intake, energy balance, both centrally in the brain and peripherally, even in the gut, gastrointestinal system. And in fact, the upregulation of the, or dysregulation of the endocannabinoid system in the gastrointestinal tract has potential impact on inflammatory bowel disease. And overall, the nutritional relevance of the endocannabinoid signaling has a role in obesity, cardiovascular pathology, and gastrointestinal diseases. So the most fascinating part here is that an unexpected source of endocannabinoids was found in truffle, especially in the black truffle, Tuber melanosporum. So the endocannabinoids are produced and the production increased during the maturation. And these endocannabinoids are much older than the plant cannabinoids that are found, for example, in cannabis sativa. So it seems that these endocannabinoids are much more ancient than phytocannabinoids, and not vice versa, as it could have been hypothesized. So this opens new perspectives in the evolutionary role of endocannabinoids in truffle and in fungi. It confirms the idea that fungi are a reservoir of evolutionary conserved molecules with a role, a very important role in animal and human physiology. So to conclude, we can see that the hidden potential in the fungal biodiversity has a lot yet to be explored, and a lot of potential application in human well-being, as it was the link with the the link between biodiversity exploration and not only we can think of fungi and truffle as of course delicious ingredients in cuisine, as we are just going to appreciate, but also as complex biochemical factories that produce a number of bioactive molecules with a number of roles that can be very relevant for human health. Thank you for your attention.
Thank you very much, Antonella and Maria Benedetta, for this presentation. I think that after this morning session, we have some more knowledge about olive oils, truffles, minor cereals, mushrooms. So it's very interesting what all of you presented. And now we are going to have a very special moment. We have 2 tasting sessions. The first one is organized by the World Truffle Academy, and the second one is organized by the Polytechnical University of Marche Region in Ancona. So I'm very honored to introduce you the president of the World Truffle Academy, Giuseppe Cristini, that is coming. He is not yet ready. And he will make a presentation at first of the ingredients that will be used for the recipe, for which we will have a taste that has been prepared by the restaurant that is upstairs. So they are going to bring down all the dishes ready for the tasting. So, Commander Giuseppe Cristini, welcome, and thank you for the organization.
Prego. Buongiorno a tutti. Avevamo previsto inizialmente la nostra diciamo, narrazione in inglese, ma stanno arrivando 13 giornalisti giapponesi e ci hanno chiesto di parlare in italiano. Per voi la signora tradurrà gentilmente in giapponese, e quindi è questo che ci ha chiesto naturalmente l'organizzazione, e vedo con piacere anche il commissario Vattani.
皆様こんにちは。これからトリュフに関するご説明をご紹介をいたしますけれども、この後13名ほどのジャーナリストの方もお越しになりますので、イタリア語、そしてそれを私が訳させていただきます。よろしくお願いいたします。
Oggi vi presenteremo una degustazione narrata.
本日はお話をご紹介をしながら皆様にトリュフをテイスティングしていただきます。
Con il sostegno di Italy abbiamo pensato a un piatto della perfezione italiana, il tartufo.
イタリアの最も、宝と言われておりますトリュフを皆様にご提供いたします。イタリーさんのご協力を得ております。
Ecco, quindi sostanzialmente cercheremo di parlare del piatto quando vi sarà giunto al vostro palato, e naturalmente narreremo.
皆様のお手元にお皿が届きましたら、そのトリュフについてご紹介をさせていただきたいと思っています。
Narreremo ogni singolo ingrediente in una gestualità amabile e di grande piacevolezza.
そしてきっと皆様にも気に入っていただけると思いますけれども、そのお味、香りについてご説明をさせていただきます。
Sì, direi che a questo punto manca ancora qualche minuto perché Italy scenderà con i piatti.
まだこれからイタリーの方々が調理されたお皿を持って皆様のところに参りますまで数分かかります。
Intanto io comincerò a mostrarvi una grande pepita.
その前に皆様にこれからではトリュフをご紹介させていただきます。
E comincerò a raccontarvela.
トリュフについてお話をさせていただきます。
Sì? No, ma non iniziamola. Ah, dobbiamo aspettare anche la narrazione, ho capito. Sì. Giusto. Benissimo. Sì, ci sono dei video, possiamo andare con un video.
メディアの方々がお揃いになるまで、しばらくこのお話を、お待ちいただきますが、その間に皆様には映像をご覧いただきます。
Un'alba, le ombre, il bosco, il cagnolino, il cavatore, un raggio di sole, l'ambiente immacolato, il tartufo che Madre Terra nasconde per arrivare al piatto della perfezione. Il tartufo tra mistero e realtà, tra magia e cucina. La magia è il mistero delle ombre, di una spora, del fiuto del cane, di un alito di vento che gli indirizza il profumo. E poi tra realtà e cucina, il piatto della perfezione nel mondo.
Puoi mettere la voce anche. Ci siamo? Bene, torniamo in diretta. Scusate qualche minuto.
申し訳ございませんでした。では今からトリュフのご紹介をさせていただきます。
Intanto la cucina fra 2 minuti arriverà con il piatto della perfezione italiana nel mondo.
あと料理ももう間もなく皆様のお手元に届きます。
Oggi questa giornata l'abbiamo dedicata al mondo dell'Expo.
本日はこの、エキスポ万博博覧会のために
ma la vogliamo anche ben augurante per la cucina italiana, prossimo patrimonio UNESCO.
そしてまた近い将来イタリア料理がユネスコ世界遺産として認証されますことを願います。
Il tartufo italiano a supporto della candidatura della cucina italiana a patrimonio UNESCO.
特にこのトリュフという食材はユネスコ世界遺産にイタリア料理がイタリアの食材が認証されることのキーポイントになります。
Il tartufo va sempre accarezzato in guanti bianchi.
トリュフは必ず白手袋を履きまして優しく触らなければなりません。
È un gesto d'amore verso questo miracolo della natura e verso l'ospite che lo degusta.
これは自然の中から生まれた奇跡であり、また皆様にお届けするためにこのように手袋を使っております。
Abbiamo una magnifica pepita di tartufo nero estivo.
これはサマートリュフでして黒トリュフと呼びます。
Volgarmente detto scorzone.
スコルツォーネ、つまり大きなかけらというのは俗語でございます。
Se vedete il peridio si presenta piuttosto rugoso, ma questa è l'indole del tartufo nero estivo.
表面が非常にざらついた感じなのですが、これがサマートリュフの特徴でもあります。
La gleba è color nocciola, un marroncino che denota perfetta maturazione.
そして中はヘーゼルナッツのようなそういった優しい色をしております。
Il profumo è ampio e spedito.
香りは広く深く香ってきます。
Richiama naturalmente la nota funginea, ma anche un toccante senso di nocciola.
キノコの種類ではございますので、そういったキノコの香りが少し、そしてその奥にヘーゼルナッツの香りがします。
Generalmente la raccolta del tartufo estivo inizia dal 1 giugno e termina il 31 agosto.
サマートリュフの収穫時期は6月1日から、そして最後は8月末まででございます。
Si presenta già una buona stagione e anche se siamo all'inizio le pepite cominciano ad avere molto profumo.
そして今年は非常に収穫量もよく、またトリュフの香りが非常にいい豊富な年とされています。
Puoi mettere qui? Ecco, questo è da fotografare assolutamente. Ci stai dicendo che stanno arrivando i piatti, cara? Tra pochissimo. Questo è il piatto che degusterete, veramente è da fascino. Io credo che sia veramente da fascino.
皆様のお手元にも同じお料理が届きますけれども、香り豊かな素晴らしいお料理です。
Il tartufo, come dicevo, è un miracolo della natura, vegeta nelle migliori condizioni.
トリュフというのは自然の奇跡と呼ばれています。なぜかと言いますと、自然条件が揃わないとトリュフが生まれてこないからです。
Il tartufo è anche un cibo per sognatori.
夢見る人のための食材とも言われています。
È un simbolo sicuramente della biodiversità italiana.
特にイタリアの生物多様性を最も表現している食材の一つです。
Espressione dei migliori terreni conservati in madreterra Italia.
つまりイタリアの肥沃な土地、そして長年それを守ってきたことの証とあります。
Abbiamo in mente generalmente il tartufo bianco pregiato.
よく世の中で広く知られているのは白トリュフですね。
O bianco o di alba o di aqualagna.
白トリュフもしくはアルバのトリュフというのは皆様もお耳にされたことがあるのではないでしょうか。
Però quello la troveremo solo da ottobre a gennaio.
この白トリュフは10月末から1月ぐらいまでの限られた季節にしか見つかりません。
E per finire, naturalmente diciamo che il tartufo in Italia ce lo abbiamo 11 mesi all'anno.
イタリアではトリュフの収穫時期が1年のうち11ヶ月にわたります。
Perché generalmente il mese di maggio la natura si riposa.
なぜかと言いますと、5月だけは自然が環境が休む休息時期になるからです。
E credo che una grattugiata o una lamellata di tartufo davanti all'ospite, davanti ai nostri occhi, sia un gesto d'amore.
トリュフを薄く削る、もしくは細かく削ることはお客様にとってお客様を魅了するものであります。
Sua Maestà il tartufo, ripeto, vegeta solo in terreni integri e immacolati.
そしてよく言われるのは、このトリュフが育つ土地というのは非常に肥沃で内側にあり、人に荒らされていない重要な土地です。
Ecco, sul tartufo poi ne riparleremo mentre degusterete il piatto.
ではトリュフについては皆様がテイスティングをされてご試食されていらっしゃる間に続けてご紹介いたします。
E questo è il nostro oro nero.
私たちはこれを、ブラックゴールドと呼んでいます。
Ma nel piatto che degusterete, che lancia la cucina italiana patrimonio UNESCO, assaggerete anche i capelli d'angelo, maccheroncini di Campofilone.
そして今日はですね、皆様のためにこの非常に細麺のパスタ、カペッリダンジェロ、天使の髪の毛という名前がついたパスタとあえてご提供いたします。
Dall'oro nero passiamo all'oro giallo.
黒いゴールドからイエローゴールドに移ったような形です。
E poi non può mancare l'oro verde, il nostro meraviglioso, già detto, olio extravergine di oliva.
そして欠かすことができないグリーンの今度はゴールド。これがオリーブオイルです。
E un elisir di lunga vita.
これは非常に健やかな人生を与えてくれます。
Una ottima bottiglia d'olio non può mancare in nessuna casa del mondo.
世界中のどの家庭でも本当にクオリティの高いオリーブオイルは不可欠です。
Ricchissimo di polifenoli e con profumi seducenti.
ポリフェノール値の含有量が高く、そして豊かな香りに包まれます。
Dopo l'oro nero, l'oro giallo e l'oro verde, qui abbiamo l'oro bianco.
そして最後に白いゴールド、それが手元にございます。
Grana padano 30 mesi biologico.
これはオーガニックのグラナパダーノ30ヶ月熟成チーズです。
Le mucche pascolano nei prati stabili a 1000 metri.
標高1000メーターのところで、放牧された牛のミルクから作られています。
E questo è l'oro bianco.
これは白いゴールドと私どもは呼んでいます。
Ora sono arrivati i primi piatti. Io credo che sarebbe bello, ciascuno, ne arriveranno altri, si alza e degusta il piatto.
それでは皆様のお手元に最初のお皿が届いたようですので、どうぞお席をお立ちになり、お皿をお手にしてくださいませ。
E poi ci risediamo e continueremo a parlare del
その
piatto.
後もう一度おかけいただきまして、このトリュフのお話を続けさせていただきます。
Nel frattempo è arrivato anche il vino e possiamo alzarci e io mi sposto a servire dei calici di vino
そ
intanto.
れではワインも届いたようでございますので、皆様に私はワインをサービスさせていただきます。
Prego, prego.
different species in all phases of life cycle.
Please take a seat. We are starting the second part of the tasting. Now we are talking about olive oil, and the presentation of this tasting, I apologize, before I mentioned the Polytechnical University of Marche, but the presentation of olive oil is made by the University of Perugia. So I'm inviting the professors of the University of Perugia for the olive oil tasting. Please take a seat. Okay, prego.
Thank you, Professor Moss, again. Welcome, everyone. I don't know if I have to speak in English or Italian. I don't know if the audience can understand English or Japanese. Okay, okay, well, good, perfect. But the presentation is in English. Okay. Benissimo. Vuoi micio per la degustazione? Sì, sì, però ecco, faccio una breve presentazione, una molto breve presentazione. Sorry. Okay. I have to go forward. Okay.
では今からオリーブオイルに関してのプレゼンテーションを行わせていただきます。
Io introdurrei l'argomento dicendo che l'analisi sensoriale degli alimenti è molto importante per determinare la qualità del prodotto.
食品のクオリティを決定づけるために、官能分析というのは必ず欠かせないことであります。
Per l'olio extravergine e l'analisi sensoriale degli alimenti in generale coinvolge i sensi dell'udito, della vista, dell'olfatto, del gusto e del tatto.
皆さんもですが、美味しいと感じられるとき、これはまず目で見て美味しそうだなって感じて、そしてその次に実際に香りを嗅いでみて、あ、これは美味しい香りがする、そのように感じられると思います。食品が美味しいか美味しくないか、これを判断するのは人間の、視覚とそして、収穫です。
Per l'olio extravergine di oliva l'analisi sensoriale è ancora più importante per l'apprezzamento da parte del consumatore, per la determinazione dell'autenticità del prodotto e, in base al nostro regolamento europeo, anche per definire la classe di appartenenza dell'olio.
オリーブオイルについてはじゃあどうかって申し上げますと、オリーブオイルはさらに重要になります。つまりオリーブオイルというのにはオリーブオイルにはカテゴリーがございますが、このカテゴリー分けをするのは、収穫となりますので非常に重要になります。
Per esempio, per essere un olio extravergine, un olio non deve avere nessun difetto e deve avere la sensazione di fruttato presente.
まずエキストラバージンオリーブオイルの場合、これは何らかのディフェクトが全くないというのが非常に重要です。
Okay. Altrimenti viene declassato in olio vergine di oliva e, se è ancora più evidente il difetto, in olio di oliva lampante, che non è commestibile per l'uomo e può essere nuovamente rimesso in commercio dopo il suo processo di raffinazione.
例えば収穫で確認をしたときに何らかの血管の香りがするということが分かった場合、その場合にはカテゴリーが下のレベルに落ちるか、もしくは場合によっては口にしてはいけないというレベルの場合もございます。そのために収穫、そして、口中での確認というのはマストです。
Andando a vedere quali sono quei composti che in realtà nel gergo sono definiti stimoli chimici che vanno a interagire con i nostri recettori umani, dobbiamo ricordare clorofille e caroteni per il colore, i secoridoidi, in particolare i derivati dell'europeina e delle gustroside per le sensazioni di amaro e piccante, e di composti volatili per la sensazione olfattiva. Alcuni considerano anche la composizione acidica, specificatamente il contenuto in acido oleico, per la fluidità dell'olio, quindi altre sensazioni tattili.
実はオリーブオイルの官能評価というのは非常に科学的なものでございます。香りはどこから立つかっていうと化学分析できっちりと証明はされています。例えば皆さんが口中でオリーブオイルを召し上がった時に感じる辛み、いわゆるポリフェノールですが、これはエウロペインから来ています。見た時にイエローで美しい美味しそうな色をしていると思います。これはカロテンです。すべてが化学分析によって証明づけられるものであります。
Ok. E per quanto riguarda il colore dell'olio, questo è dato da clorofille e caroteni e i loro derivati anche dell'ossidazione. Ma essendo questi composti altamente variabili in concentrazione per effetto della cultivar, quindi la biodiversità, piuttosto che del momento della maturazione dell'oliva, questo parametro non viene considerato come da valutare nella valutazione ufficiale per la classificazione degli oli secondo il regolamento attuale europeo. Infatti non c'è nessun descrittore, questa è la scheda ufficiale di analisi riferita proprio al colore.
そして今皆様が見ていただいているこの官能分析の表があります。これというのは EU の中でルール付け、つまり法律としてこれが認証されているものです。つまり全てこういった法律にのっとって色がどのような状態なのか、そういったものを分析いたします。ちなみに色についてですが、これは品種によって色が変わる場合があります。また実の熟成の速度によっても変わりますので、色とそしてクオリティというのは直接的には結びついておりません。
E infatti per l'analisi ufficiale dell'olio, secondo quanto stabilito dal Consiglio Oleicolo Internazionale e quindi da tutti i paesi che naturalmente utilizzano questa tecnica, il bicchierino ufficiale di assaggio deve coprire il colore dell'olio, perché il colore potrebbe fuorviare il giudizio del consumatore, anzi scusa, dell'assaggiatore, che è un assaggiatore esperto nel valutare sia i difetti che i pregi dell'olio.
非常にエキスパートな鑑定士におきましても色に左右されることがあります。見た目の色が美味しそうだなと思うとついつい人間ですから左右されることがないようにご覧になっていただきますように、ブルーのグラスとか赤いグラスで中身の色が見えないようになっています。これが公式の官能分析を行う時のグラスです。しかも上に蓋を乗せて香りが飛ばないようにしています。
Però vediamo invece quali sono le sostanze importanti. Oggi andremo a valutare anche il colore del prodotto perché faremo una prova abbastanza, come dire, non formale. Però i composti da valutare sono sicuramente quelli volatili che si generano per diverse vie. Quella positiva è quella di cui abbiamo parlato stamattina, cioè la via della lipossigenasi che si attiva durante la frangitura delle olive e che dobbiamo anche preservare, come dicevo stamattina, cercando di limitare le alte temperature, perché le alte temperature, parlo anche di temperature oltre 25 gradi centigradi, potrebbero danneggiare la parte aromatica. E questi sono i composti positivi che danno la sensazione di fruttato che andremo oggi a studiare.
この後に実践的に皆様にはオリーブオイルをテイスティングしていただきますけれども、オリーブオイルにはその中にリポキシナーゼという成分が含まれているためにそこから香りが立ちます。今皆様に見ていただいている表がまさにそれなんですけれども、品種によって多様性がございますのでさまざまな異なる香りを感じていただくことができます。
Perfetto. Purtroppo però non sono solo gli unici composti che possono caratterizzare l'aroma di un olio, anzi molti sono chiamati difetti e si generano per diverse vie. Alcune si generano per una errata o prolungata conservazione delle olive. Si raccomanda infatti di non conservare mai le olive perché è una pratica che può portare alla produzione di sensazioni molto sgradevoli come avvinato, riscaldo, muffa.
先ほど皆様に見ていただいたのはポジティブな香りの種類でした。今度は今皆様に見ていただいているのはネガティブな香りです。たとえ非常にクオリティの高いオリーブオイルでも時間が経ち保存状態が良くない、もしくは非常に室温が高いところに保存していると香りはやはり失われていきます。そうすると何が起こるかというと酸化が始まり、そしてディフェクトと言われる一番左側は実の中にハエが卵を産みつけている様子ですけれども、それ以外にもリスカルドとかさまざまなディフェクトがあります。
Perfetto. Ci sono anche altri difetti che invece si generano, per esempio, per una prolungata o cattiva conservazione del prodotto finale, ossia dell'olio. Il difetto tipico è quello del rancido, per esempio, perciò bisogna fare molta attenzione a conservare l'olio in luoghi lontani dall'esposizione della luce, dell'aria e anche delle alte temperature.
例えば製品になった後でもボトルを温度の高いところに保存したり、もしくは直射日光が当たるようなところにボトルを置いておきますと酸化が始まり、そして最終的には中のオリーブオイルがランチドと言いますけれども、酸化臭がするディフェクトのあるオイルになります。
E infatti, andiamo avanti su questa parte, la scheda ufficiale di assaggio dell'olio dà molto spazio alle sensazioni negative, ossia difetti. Ricordo, per il regolamento europeo questa parte non deve essere proprio considerata se l'olio è extravergine, cioè l'olio deve essere privo di difetti. Non so se questa parte può essere interessante oppure no.
特にエキストラバージンという定義はいずれのディフェクトもない完璧であるということになりますので、今見ていただいているような官能分析表の中にディフェクトの種類を明記するというような、また強度を明記するという表がございますが、エキストラバージンオリーブオイルの場合にはそれは使わない、つまりその必要がないということになります。
Al contrario, un olio che sia appunto extravergine ma anche vergine deve avere la sensazione del fruttato, quindi una sensazione positiva data da quei composti che si generano durante il processo di estrazione maggiore di 0, quindi presente.
ただバージンオリーブオイルの場合にはオリーブオイルとしての香りは残っていて、その中にだけれどもわずかなディフェクトがありますので、それを明記して強度も書いていく、そういった官能分析表が必要になります。
Passo avanti su questa parte, ma è interessante poi per chi ha interesse a prendere la presentazione è a disposizione. Il Consiglio Oreicolo Internazionale descrive nel suo vocabolario tutti gli attributi di tutti i sensi, naturalmente olfattivi, gustativi e tattili. In questo caso trovate quelli positivi del fruttato.
今見ていただいているのはポジティブな場合の官能分析で行う評価のポイントです。フルイティ、フルーツの香りがするかどうか、グリーンかライプ、つまり新鮮か熟しているか。
Però descrive anche i difetti, quelli di cui vi parlavo prima, cioè quelle sensazioni che un olio non dovrebbe avere perché non danno piacevoli sensazioni, danno sensazioni sgradevoli.
あと今皆様が見ていただいているのはディフェクトと言われるネガティブな評価の場合、ここで出ている土の香りがするとか、それからカビ臭であるとか、アルコール臭がする、そういったいろんな種類がありますけれども、こういった言葉はすべてルール作りが徹底的に行われておりますので、 EU 法の中で決められた言葉を使って表現することになります。
Andiamo avanti, quindi sono tutte descrizioni dei difetti queste. Passerei a una parte importante, dopo che, poi vi dico le sequenze precise, dopo che abbiamo annusato le sensazioni olfattive andremo a provare a gustare l'olio. In bocca noi abbiamo la possibilità di percepire l'acido, il salato, l'amaro, il dolce e l'umami, che è una sensazione molto presente nel cibo giapponese.
鼻だけで収穫だけでテイスティングをするのではなく、官能分析の場合には今度は口の中に入れてそれを確認作業いたします。 口の中で感じるものっていうのは通常塩辛いかどうか、あと辛み、そして酸っぱい、酸味、そして甘み、そして最後にこれは日本語がそのまま世界共通語になっております。日本から生まれた言葉、うまみという言葉があります。
Cosa possiamo percepire di sensazioni gustative dell'olio? Non possiamo mai dire che un olio al gusto sia acido, perché gli acidi dell'olio sono così grandi da non poter interagire con le nostre papille gustative, con i nostri bottoni gustativi.
よく頻繁に間違いが起こるのはオリーブオイルの酸度という言葉がありますが、この酸度は口の中で感じられる酸度ではありません。官能分析ではなく化学分析の中で出てきた酸度のことを言います。というのは酸度が口の中で感じられる場合というのはもうそれはディフェクトですので、官能評価には値しないということになります。
Non possiamo nemmeno dire che un olio sia salato perché non contiene nessun sale.
あとオリーブオイルが塩辛い、これもありません。オリーブオイルの中には塩分が含まれていません。
Possiamo dire che un olio è dolce ma non perché contenga zuccheri, solo perché qualche olio ha la sensazione di amaro, che descriveremo fra poco, molto molto bassa. E allora si dice in gergo che l'olio è dolce.
ただオリーブオイルが甘い、これはお砂糖が含まれている甘さではなく、オリーブオイルそのものが苦みが少なく甘み部分が強いということで、このオリーブオイルは甘いという表現をすることはあります。
Invece sensazioni molto importanti per quanto riguarda le sensazioni gustative, anche se qui non riportata, è l'amaro. La sensazione amara in un olio è positiva ed è correlata o correlabile alla presenza di sostanze fenoliche che ci fanno bene anche alla salute. Quindi indirettamente possiamo capire anche che un olio ci sta facendo bene se risulta essere amaro. L'amaro si percepisce in fondo alla bocca, sulla parte basale della lingua.
口の中で苦いと感じるオリーブオイルが時々あります。これはフェノールを皆さんが感じていらっしゃるということで、非常にポジティブなことなんです。苦いオイルというのはつまり抗酸化要素を多く含んでいるということになります。苦みを感じる部分というのは口中でも一番奥のところ、舌の上で感じます。
Altra sensazione molto importante e positiva è quella di piccante o pungente. Anche questa è positiva e descrive un olio di qualità e anch'essa correlata alla presenza di composti fenolici che ci fanno bene. Quindi, riassumendo, se un olio amaro e piccante vuol dire che è un olio che ha un buon contenuto in composti fenolici, quindi è un olio che si conserva meglio in condizioni adeguate e ci fa anche bene alla salute.
そしてオリーブオイルが辛いと感じることがあります。これは逆に必須条件なんです。エキストラバージンオリーブオイルには辛みがなければなりません。これも同じようにフェノールを皆さんの口中の中で感じていらっしゃいます。フェノール値が高く、そして辛みが多く、苦みが多いということは、それだけフェノールがたくさん含まれているということですから、オリーブオイル自体の賞味期限も長くなります。もちろん一定の良い条件の中で保存していただく必要はございます。
Quindi abbiamo descritto le sensazioni che andremo a valutare fra poco. Io vado molto veloce adesso perché... Ah, scusate, questa la devo far vedere. Naturalmente la scheda ufficiale di analisi dell'olio prevede anche che l'olio abbia le sensazioni positive di amaro e pungente, a ribadire quanto siano importanti per la qualità del prodotto.
ですからプロの鑑定士が使う官能分析表の中には辛み、そして苦みを必ず数値で明記するという部分がございます。これは両方なければならないからです。
Devo andare avanti perché è arrivato il momento di assaggiare l'olio. Qui sono riportati tutti i fattori genetici, geografici, agronomici e tecnologici che possono variare la composizione in sostanze fenoliche e volatili in particolare, ma siccome ne abbiamo già parlato stamattina, comunque chiunque fosse interessato, la presentazione è a disposizione.
そして午前中にもご紹介したことですが、オリーブは品種がたくさんイタリアにはあります。オリーブは 他の植物やフルーツと同じように品種によって特徴が異なりますので、中に含まれている抗酸化要素の、価値も値も変わってきます。これからでは実際にそれを皆さんにテイスティングしていただいて体感していただきたいと思います。
Oggi proveremo a fare un'analisi descrittiva di un olio. Quella che avete sulla sedia, quelle che avete sulla sedia sono due schede. Una è la scheda ufficiale di analisi dell'olio secondo il regolamento europeo e stabilita dal Consiglio Olicolo Internazionale. È solo per farla conoscere, ma non la utilizzeremo.
皆様のお席に官能分析表がお手元にあると思います。これを使っていただかなくても結構です。こういった表を使って鑑定士が評価をするんですということをお伝えするためにご用意いたしました。
E di seguito quindi avete delle vignette che descrivono diversi passaggi che dobbiamo fare per valutare l'olio. Lo faremo e abbiamo a disposizione 4 oli italiani. Naturalmente non valuteremo i difetti, quindi solo i pregi dell'olio.
今日皆様のためにご用意したオリーブオイルはすべてエキストラバージンですので、欠陥やディフェクト問題はありません。今日は皆様にお楽しみいただけるように4種類のオリーブオイルをご用意しています。すべてイタリア産のものです。
E ora possiamo cominciare e abbiamo anche la possibilità oggi di valutare il colore, se vogliamo, perché sulla scheda è presente anche il descrittore del colore, ma questa è una valutazione non ufficiale, in quanto, vi ripeto, che la scheda ufficiale non prevede la valutazione del colore.
今日皆様には一応色の評価もしていただけるようにこの透明なグラスを使いまして表もご用意していますが、本来正式な公式な官能分析の時には色は全く関係ありませんので、色の評価というのはいたしません。ただ今日はちょっと色を見て楽しんでいただけるように透明なグラスをご用意しています。
Come utilizzare la scheda? Naturalmente è una prova, quindi tranquilli, non c'è niente diciamo di ufficiale da fare. Per i descrittori della vista ci sono per la vista ci sono dei descrittori, ci sono altri per l'olfatto, altri per il gusto ed altri per il tatto. Vicino ad ogni descrittore c'è una linea e voi dovreste porre una linea perpendicolare appunto alla linea vicina al descrittore, valutando l'intensità. Più state lontani dal descrittore e più vuol dire che l'intensità è elevata.
皆様のお手元にある官能分析表にはグラフになっていて、そこのちょうど当たる部分にチェックを入れるようになっています。ですからそれが、離れたところにチェックを入れれば入れるほど強度が高いという意味にはなります。今日皆様に書き込んでいただいてご提出いただく必要は全くございませんので、こういうものなんだなということで、ご参照までにどうぞご覧くださいませ。
Quindi proviamo a fare questa prova e questo è un bicchierino che consente anche di coprire il bicchiere ed è questo un aspetto importante perché coprendo il bicchiere e facendo questo piccolo movimento riscaldiamo il bicchiere e facciamo in modo che i composti volatili vadano più abbondantemente su questa parte. Cioè sul spazio libero sopra il bicchiere, sopra l'olio.
少しグラスをこう持っていただくと、この人の体温で少し温まります。温まるほど香りが立ってきますので、そのために蓋を閉めた状態でお手に持っていただいて少しこのように温めていってください。
A questo punto facciamo quello che c'è scritto lì. Andiamo a togliere il coperchietto
蓋を取って一気に香りを嗅いでみましょう。
ed annusiamo. Prima facciamo delle valutazioni brevi, poi sempre più profonde.
ここで大切なのはまずは第一印象です。 その次にもう少しこれは何の香りがするのかなっていうふうに考えます。
Bene, a questo punto dobbiamo prendere una piccolissima quantità di olio e la mettiamo in bocca e facciamo in modo di tenerla tra il labbro inferiore e i denti stretti.
そして次に今度は口中で確認をします。その時には少しオリーブオイルを口に含んでいただいて、歯を閉じて口は開けてください。で、歯の隙間から空気を吸い込みます。
Una piccola quantità, mi raccomando.
たくさん吸い込むと、すごいオイルを口に含むと辛いかもしれません。
A questo punto però dovete fare questa cosa qui. Dovete aspirare aria, prima in maniera gentile, poi in maniera un po' più aggressiva.
最初はゆっくり、次にぐっと思い切り空気を歯の隙間から吸い込んでみてください。
Questo consente all'olio di arrivare fino alla base della lingua dove dobbiamo sentire l'amaro e poi gli consente anche di, tra virgolette, vaporizzarlo in maniera che tutti i nostri bottoni gustativi vengano coinvolti.
そうすることによって喉の奥までオリーブが回りますので、鼻腔を通じてもう一度オリーブオイルの香りが口の中に戻ってきます。あと口中は温度が高いですからより温度を感じます。辛みを感じてらっしゃると思います。
È normalissimo l'effetto.
それが正しい
sì,
反
ci
応
può
です。
stare.
辛いのが。
A questo punto cercate di togliere l'aria dalla bocca facendolo passare dal naso.
ゆっくり鼻腔を通ってもう一度口の中にオリーブオイルの香りが戻ってくるのを楽しんでください。
Questo serve a far sì che anche il nostro sistema retroolfattivo nasale venga coinvolto e ci consenta di percepire quello che viene chiamato flavor di un alimento, in questo caso dell'olio.
特に食事が美味しいかどうかというのは実は香りで決まるものなんです。ですのでゆっくりとこの残り香を、体感していただきたいと思います。
Ci siamo, abbiamo concluso. Se abbiamo informazioni a sufficienza per compilare la scheda, non ci resta altro che eliminare l'olio dalla bocca, ma probabilmente l'abbiamo bevuto, ma non fa niente, anzi ci fa bene, perché questo è anche bello ricco di fenoli e quindi una bella fonte anti-aging.
抗酸化要素が非常に高いオリーブオイルを皆様のお手元にお配りしていますので、もうしっかり飲んでいただくのが一番です。
Bene, se vogliamo chiedere magari a chi ha fatto l'assaggio quali sono le sensazioni che hanno percepito all'olfatto, al gusto e al tatto.
今オリーブオイルを味わっていただいた方にどんな感じだったかちょっと印象を教えていただけますか？
Qualcuno di voi ha percepito all'olfatto sensazioni positive di fruttato, di foglia, per esempio? Erba tagliata. Che olio è questo? Lidrana. Lidrana questa. Ok, questo è un olio monovarietale, cultivar Lidrana, una cultivar laziale, sì.
今皆さんのお手元にお配りしたのは単一品種のエキストラバージンオリーブオイルで、品種名はイトラーナと言いまして、ラツィオ州の原品種です。
Lazio è una regione del centro Italia. Centro.
ラツィオはローマを州都とします非常に重要な州ですね。
Giustamente la mia collega mi ricorda di ricordare dove c'è Roma, la città, la capitale. Ok. E è un olio vincitore del premio Ercole Olivario.
今このテイスティングしていただいたオリーブオイルはエルコレオリバリオというイタリアの非常に大きなオリーブオイルのコンペティションがあります。それで受賞したオイルです。
Al gusto come vi sembra? Amaro, piccante, Quali sensazioni? Ricordo che un olio non può essere definito né acido né salato.
オリーブオイルは今テイスティングしていただいたように塩辛いとかそういう表現はなく、今召し上がったオリーブオイルはかなり辛かったり苦かったりしたと思います。これは抗酸化要素が非常に多く含まれているからです。
Che livello di amaro e piccante diamo a questo olio? Medio,
Dov'è, no?
un medio livello, perché l'itrana è proprio una cultivar che ha un medio contenuto di composti fenolici.
だいたいこのイトラナ品種は中ぐらいの強度のポリフェノール値が含まれていますので、辛み苦みがいずれもミディアムになります。
Bene, e se avete domande al riguardo, altrimenti passiamo al secondo assaggio.
もしよろしければ2つ目のオリーブオイルのテイスティングに移りたいと思います。
Okay. Avete domande?
ご質問がございましたらどうぞ。大丈夫ですか? Andiamo al secondo.
Ok, perfetto. Passiamo al secondo. Queste bottiglie sono tutte scure. Abbastanza scure. Sono tutte scure, non è... Sì, prego.
Prego.
Grazie per la domanda. Non ne ho la più pallida
ご質
idea.
問がありましたので皆さんにも訳させていただきますね。
Le bottiglie dell'olio possono dare un'idea della qualità del prodotto e soprattutto di quanto il produttore abbia intenzione di mantenerlo bene, il prodotto.
ご覧になっていただきますと分かりますように、オリーブオイルはすべて遮光瓶に入っています。皆様も選ばれる場合にはこういった遮光瓶に入って光を通さないオリーブオイルを選んでください。
Le bottiglie scure danno una maggiore garanzia di protezione contro il nemico numero uno dell'olio, che è la luce.
オリーブオイルの一番の敵は酸化なんです。光を通すことによって酸化しますので遮光瓶は重要です。
Quindi consigliamo sempre di conservare l'olio in bottiglie scure, altrimenti di conservarle in luoghi bui ed evitare che ci sia tanto ossigeno all'interno, tanta aria, quindi di consumarle più brevemente possibile.
オリーブオイルを購入されるときはできるだけ小さいボトルを購入されて早く使い切るというのがベストです。ボトルの中にも開いてくると酸化が始まりますので、なるべく空気が少ない方がベターです。
Bene, passiamo al secondo assaggio.
Sì.
Molto bene. Quindi sapete già cosa fare, siete diventati già bravissimi.
もう皆さんテイスティングの仕方を覚えられたかもしれません。先ほどと同じように少し蓋を閉めた状態でグラスを温めましょう。
Ok, apriamo il coperchietto.
開けて香りを確かめてください。Sì, è più pomodoro.
Sì, questo è un olio decisamente diverso rispetto al primo, con sensazioni olfattive molto particolari, abbastanza comuni per diverse varietà italiane.
先ほどのオイルとは全く違う香りがすると思います。イタリアの品種によく見られる傾向で、似通ったこの香りを持った品種は多くあります。
Naturalmente siamo sempre nell'ambito della sensazione del fruttato, quindi positiva, di un fruttato verde, però le note molto interessanti sono quelle di pomodoro.
一番中心の香りはトマトの香りです。トマト以外の香りもしますが、このトマトの青いトマトの香りというのがこのオイルの特徴ですね。
Un'altra volta proviamo a fare l'assaggio, quindi una piccolissima quantità e aspiriamo aria.
そして今度は口に入れてテイスティングいたします。
Mi è passato il raffreddore, tutto quanto. bello piccante. Qui
辛みが強いですよね、
prego.
さっきのものより。
Sì, vai. Vai tu, tanto lo conosci il prodotto. Naturalmente in bocca andiamo a percepire le sensazioni di amaro e piccante principalmente, e qui sono particolarmente presenti.
特にその辛みとか苦みっていうのは一番最初に口中で感じるものなのです。ですから最初に今辛みを感じられましたが、ポリフェノール値が高ければ高いほどこの辛みも感じます。つまり抗酸化要素がたくさん入っているということです。で、最初に鼻で感じた香りが口中でも確認ができましたでしょうか。同じような香りがしますか？
Ok. Sì, abbiamo abbastanza sensazioni, abbastanza chiare le sensazioni percepite, possiamo degustare, possiamo ingoiarlo, non abbiamo la possibilità di espellerlo, lo beviamo, ma ci fa bene, rimane sempre lo stesso concetto, che ci va bene. E vorrei aggiungere che è un olio monovarietale anche questo, una cultivar molto particolare, difficilmente si trova sul mercato, si chiama ortice o ortice ed è campana, quindi del sud Italia.
今皆様のお手元にあるこのオリーブオイルですが、原品種名をオルティチェと言います。カンパニャ州の原品種で、なかなか市場では見かけない品種なので、希少品種と言えます。それだけあまりたくさんは生産されていないのですが、このグリーントマトの香りがまず有名で、そして口中では非常に辛みが強い。セロリとかそれからピーマンを食べたような辛みを感じられると思います。
Andiamo con l'ultimo assaggio.
Un altro?
Sì, facciamo no,
L'ultimo no.
hanno deciso di no perché la curatina è troppo pesante. Ce n'è un'altra ancora, no?
Per loro, però,
Non so i tempi,
Ok.
sinceramente come siamo con i tempi? Ci siamo? Ok. Allora, quindi il penultimo, questo non è più l'ultimo. E stessa cosa, ripetiamo le stesse operazioni. Quindi
Questo è penultimo, quello di
penultimo.
Ortice?
No, l'ortice l'abbiamo fatto. Ah, scusami, non te l'ho dato. Quindi vabbè, abbiamo imparato innanzitutto che un olio deve essere amaro e piccante per contenere sostanze che fanno bene alla salute.
今日は皆様にオリーブオイルは辛くなければいけないというのを学んでいただいたと思います。辛いイコールエキストラバージンオリーブオイル。逆に言うと辛くないイコールエキストラバージンオリーブオイルではないということになりますので、今日お帰りになられたらお家にあるオリーブオイルを飲み比べてみてください。Quando tornano a casa possono provare.
Sì, però è normale che non tutti gli oli possono, anche se prodotti bene, possono avere lo stesso livello di amaro e piccante, proprio perché quella biodiversità di cui abbiamo parlato crea delle cultivar con quantità più alte, come la coratina, e quantità più basse, come per esempio un frantoio, però questo no, questo mi sa che è bello tosto. Ma questo mi sa che è amaro e piccante uguale. Oppure il leccino, piuttosto che la dolce agogia, piuttosto che la taggiasca, che magari è più conosciuta.
オリーブオイルというのは使っている品種によって非常にこの辛みの強さ、苦みの強さも異なります。レッチーノとかタジャスカっていうのはよくイタリア料理に出てくる黒オリーブで小さいちょっと苦みのあるそれお料理に使われています。あれがタジャスカですけれども、あれがグリーンの時に絞られた時っていうのは辛みはあんまり強くないオイルなんですね。品種によってそのように特徴は変わります。だけれど辛みはなくてはいけません。強度とは別に。
Aspettiamo che tutti quanti abbiano l'olio.
お手元に3つ目のオイルが届きましたでしょうか。
E non so se nel frattempo avete delle domande.
他にご質問はございませんか。
Per quanto dicevamo del colore, per esempio, questo è un colore giallo-verde, ecco, giallo con sfumature di verde molto importanti. È normale che un olio che sia in là con la conservazione abbia un giallo molto più importante, ma non è detto che un olio che abbia un colore non così verde non sia comunque di qualità, perché ripeto, i composti che danno il colore sono molto variabili per effetto della cultivar, quindi la biodiversità, piuttosto che dell'epoca di maturazione.
オリーブオイルの香りとそして色そしてクオリティは関係がありませんので、色で見て判断をなさることはぜひ避けてください。色で見てグリーンで美味しそうだなと思ったら全く香りがないっていうことはよくあることなので、私たちも騙されやすいのですが、必ず収穫で確認をしていただきたいと思います。
Bene, tutti quanti hanno il bicchiere,
Sì.
vero? Ok.
ではテイスティ
Stessa
ングいたし
procedura.
ましょう。同じように香りを嗅いでみます。
Vuoi descriverlo tu? Prego. Sì, sì, vai.
No, io?
Sì. No, tu sei l'intenditrice,
Sì.
lo so, prego.
今皆さんどんな香りがお手元でしましたでしょうか。まず非常にグリーンの青野菜の香りがすると思います。あと青草を刈り取ったばかりの青草、あとはルコラとかハツカ大根っていうような野菜の香りがすると思います。
Anche questo è un fruttato fresco.
非常にフレッシュなグリーンの香りですね。
Sia il precedente che questo sono tutti oli che hanno vinto l'Ercole Olivario, quindi sono oli
コンペティ
molto
ション
pregiati.
で受賞しているオイルをお持ちしてますので非常にフレッシュです。
Proviamo ad
じゃあ
assaggiarlo.
今度は口中に入れて確かめてみます。
Curatina un po' bassa. Questo è frantoio. Sì, sì. Ok. Allora, la differenza è che rispetto agli altri è meno amaro e piccante. È normale che sentiate la sensazione più, diciamo, più importante di quella che effettivamente è, perché ormai abbiamo i nostri sensi piuttosto assuefatti, quindi non riusciamo bene a capire quanto sia veramente la sensazione, ma è una sensazione di amare, sono sensazioni di amare e piccante abbastanza, diciamo, sulla media, se non sotto la media.
今度もこの苦み辛みは中ぐらいなんですけれども、皆様どんなように感じていらっしゃいますでしょうか。オリーブオイルをいくつか続けて試してみると、ちょっとだんだん慣れてしまって辛みとか苦みがあまりよくわからなくなったりすることもあります。
Questa è la cultivar frantoio, è un olio monovarietale, ma la cultivar frantoio è abbastanza presente in tutto il centro Italia e ha poi effettivamente, diciamo, altre varietà minori che si caratterizzano per avere degli aspetti sensoriali molto simili.
これはフラントイオという品種で中部イタリアで多く栽培されている品種です。
Ok. Come vi è sembrato questo olio? Naturalmente, scusami, vai,
No,
vai.
no, prego, prego.
Naturalmente va da sé che anche un abbinamento con i prodotti, con gli altri alimenti, deve avere un senso logico, no? Con l'olio. Quindi quando abbiamo a che fare con alimenti, con piatti abbastanza, come dire, equilibrati, leggeri nell'aroma e nel gusto, sconsigliamo sempre di utilizzare oli piuttosto diciamo pieni di sensazioni di amaro e piccante, perché potrebbero coprire in maniera inadeguata il prodotto. Invece quest'olio si presta anche per un utilizzo abbastanza diversificato e anche per piatti molto delicati.
オリーブオイルの香りの強さ、そして辛み、苦みの強さというのは品種によって非常に異なります。皆様にはお好みのまずオイルを見つけていただき、またこの、香りとそして苦み、辛みの強度に合わせたお料理とか食材との組み合わせを楽しんでいただきたいと思います。例えば苦みが強いものを非常にデリケートなお料理に合わせてしまうとやはり苦みが立ってしまうので、そこの組み合わせっていうのは非常に重要です。Grazie.
E abbiamo fatto questa premessa perché l'ultimo olio che vi verrà presentato è un olio molto particolare che abbiamo descritto oggi anche durante il workshop, dicendo che è un olio molto ricco in composti fenolici, tanto che spesso un monovarietale di quest'olio non viene fatto perché sarebbe eccessivamente amaro e piccante. Parlo della cultivar coratina, che per natura ha un elevato contenuto in sostanze fenoliche.
最後に皆様のお手元に届いたオイル、これはいわゆるもうポリフェノールの王様と呼ばれている、世界的にも言われているものです。つまり辛みも苦みも非常に強いので気をつけてください。はい。
Quindi molta attenzione, una volta hanno usato l'olio, a prendere veramente una piccola quantità di questo prodotto, perché è una sorta di medicina.
これはもうお薬と同じぐらいポリフェノールがそれ以上に含まれています。
Ma dopo che l'abbiamo bevuto ci spariscono tutte le rughe.
でもこれを飲みますとシワが消えますよ。
E quindi beviamolo felicemente.
ですから美容にも健康にも非常にいいです。
Io non sento più, effettivamente, è bello, sì. Molto amaro, e poi il piccante si percepisce sempre anche questo in fondo, e infatti spesso è ingannevole, proprio per il fatto che va ad infiammare il nervo trigemino, è proprio una sensazione, quella pungente, come avviene quando mangiamo del peperoncino oppure del rafano, qualsiasi prodotto che abbia, al di là dei polifenoli, anche alcuni alcaloidi che danno anche questa sensazione.
口の中の奥の一番上の部分で刺激っていうものを感じるんですね。これはわさびとか唐辛子を食べた時も同じなんです。でこのオリーブオイルの中に、最後のオリーブオイルには非常に強いポリフェノール値が含まれていますので、皆様もかなり苦みを感じられたことと思いますが、これは非常に体にいいものなので薬だと思って楽しんでください。
Bene, non so se avete domande da fare, altrimenti dei consigli importanti da portare a casa. Gli oli sono, diciamo, caratterizzati da una diversità molto ampia, dovuta proprio alla cultivar, ma a tutti quei fattori che abbiamo oggi detto. Ma se vengono rispettate le caratteristiche genetiche e geografiche del prodotto, l'olio è comunque di qualità, però bisogna mantenerlo in qualità, e quindi cerchiamo di scegliere un olio con un packaging adeguato, per esempio una bottiglia scura o un cartoncino all'interno del quale mettiamo la bottiglia, e conservarlo, come dicevamo prima, in condizioni lontano dalla luce, l'ossigeno e la temperatura.
本日ここにお越しいただいた皆様には、今日エキストラバージンオリーブオイルっていうのがどういうものか、おぼろげにもご理解いただけたかと思います。品種が非常にたくさんありまして、それは生物多様性を本当にそのまま体現しているのがオリーブオイルです。ですので辛みも香りも苦みもたくさん種類があります。その中からお好みのものを選んでいただいて、選んでいただくときにはただ遮光瓶を使っているオリーブオイルをできるだけ選んでいただき、火のそばに置かない、直射日光に当てない、そして小さなボトルを選んでできるだけ早くそれを使い切ってしまってから次のボトルを当てるようにしてください。今日テイスティングしていただいた方法というのは、プロの鑑定士も全く同じ方法で官能分析いたします。今日お帰りになられましたら、お手元にあるオリーブオイルがどんな香りだったかな、確かめてみてください。ありがとうございました。
Grazie a tutti, ringrazio per la vostra attenzione, spero che abbiate apprezzato l'analisi sensoriale. Grazie ancora.
皆様ありがとうございました。
Now we take 5 minutes to reset the room, just to allow the organization to prepare the room for the next session. We can start the afternoon presentations. Please take a seat. And we are starting the second half of our workshop. And the session we are presenting now is about biodiversity, health, and well-being. We have 6 presenters, so I'm inviting Professor Paolo Lucci and Deborah Pacetti from the Polytechnic University of Marche, Ancona, Professor Pamela Lattanzi and Serena Mariani from the University of Macerata, Professor Lilia Neri from the University of Teramo, and Professor Gianni Sagrantini from the University of Camerino. Thank you, and we can start. So the beginning is from Professor Paolo Lucci.
Devo solo provare. Okay. Good afternoon. I'm going to discuss the possibility to use the food industry byproduct as a source of bioactive compound for novel materials and nutraceutical design. This is according to the last research, a large amount of food material is wasted, especially is wasted food materials providing from food processed byproducts. Especially food processing byproducts involve vegetable materials that are rich in bioactive compound and in polysaccharides, protein, and lipids. This compound can be applied for for functional food production, for nutraceutical, and also for food packaging. As you can see in the slide, the bioactive compound present in vegetable food byproduct is different. We have polyphenols, fiber, lipid, and so on. So developing edible packaging material from this kind of compounds offered a promising solution to reduce plastic waste, and so to approach a circular economy strategy. Bioactive compound can be incorporated into biopolymer-based films in order to create active packaging. So we can insert bioactive compound in a biopolymer and to formulate packaging that can be active to preserve, to prolong the shelf life of our food or our kind of materials. So we can use this kind of material to formulate a coating film, an edible coating film, useful to prolong the shelf life of our fruit. With this purpose, we have studied the use of C-phenyl byproduct insert the extract of C-phenyl byproduct, and we use the film, the edible film with ketosane alginate to produce an edible coating to preserve the strawberry. To prolong the shelf life of strawberry. C-phenyl is a typical vegetable of the central part of Italy, but also is spread in all parts of Italy, but also in Mediterranean area. This is a vegetable that have a byproduct consisting in woody stem and in flower. what we did, we prepared the edible film, the C-phenyl byproduct extract. We insert the C-phenyl byproduct extract in film forming solution with mushroom, with the chitosan from mushroom and alginate, sodium alginate. So we prepared this film solution. We added the water extract from C-phenyl, water extract that are rich in bioactive compounds such as chlorogenic acid, potent antioxidant compound, and we use to coat, to coat the strawberry. So we characterize the edible film that we produced, and we did the quality assessment of strawberry coated with the film enriched with the C-phenyl. The film that we obtain is reported in the slide, and the result of the work was that the optimal formulation of the film contain the extract, the C-phenyl byproduct extract at 6%, the sodium alginate, glycerol, and so on. This film was able to protect the shelf life of strawberry, and especially this film was an high antioxidant activity. So was the addition of the C-phenyl extract boosted the film antioxidant. So when we added the C-phenyl extract, the antioxidant capacity of the film was enhanced, and when we applied the film coating the strawberry, we obtained that the coating effectively extended the strawberry shelf life to 13 days. Usually the shelf life of the strawberry is around 6 days, not more. So was really effective in prolong the shelf life of the strawberry. We use another kind of biopolymer to produce film, and another kind of vegetable, according to the byproduct that is most produced during the industrial vegetable processing. So we studied the biofilm formed by potato starch and carrageenan, and use this base to enrich the film with broccoli byproduct. In this case, we use the powder of broccoli, and the freeze-dried broccoli. Broccoli byproduct. So was the byproduct of the food processing, or for the industrial vegetable processing, and use the broccoli powder, but also the ethanol extract in this case. Differently, what we did before, we used the water extract. And we obtained a film and we used to coat the kiwi, the slide of kiwi. So we used to coat the fruit, and we obtained that we characterized the film. We did the quality evaluation of the kiwi storage, the cold storage for cold storage, and we obtained that the coating with the powder and the ethanol extract of broccoli was promised to prolong the shelf life of the slides. The coated kiwi had less weight loss and better microbial stability in storage. So this was attribute to the fact that the broccoli has bioactive compound with antibacterial property, such as glucoraphanin, polyphenol, and so on. So they use, was an example of the use the biofilm with vegetable byproduct inserted in polysaccharide or in other kind of base film. And we see that the biofilm is useful to protect, to prolong the shelf life of our fruits. I don't know what happened, but it's not, is it Japanese? It's not Japanese, it's not Italian, I don't know. Anyway, we can go, no, okay. This is, non è it's maybe my laptop. And we can go through the use, in this case, of bioactive compound for nutraceutical purpose. We studied 10 years ago, we studied the pomegranate seeds, because pomegranate seeds derived from the industrial waste, is an industrial waste product from the juice processing, is produced in a large amount. So we study the chemical composition of pomegranate seed, and we thought to use the ethanol extract of pomegranate seed to develop a nutraceutical formulation on different kind of formulation. And for this purpose, we study the antioxidant and anti-proliferative activity. We decided to study the pomegranate seed because they are rich in particular fatty acid, in conjugated fatty acid. They are present almost exclusively in pomegranate seed. So we did the extraction with the ethanol, and we obtained the ethanol extract, and we characterized this kind of ethanol extract. This kind of ethanol extract contains lipid, and we studied different lipid inside the extract, and we see that. We have seen that the conjugate fatty acid, CLN, was present in the neutral fraction of the lipid, the ethanol extract. And we decided to test the extract in a different cell. I mean, we decide to test the antioxidant and anti-proliferative activity of the ethanol extract. The ethanol extract that we obtained from a special cultivar from Italian, that we have harvested in our campus of university, and we studied the antioxidant and anti-proliferative activity, and we have seen that they have this kind of activity. I mean, especially from breast cancer and prostate cancer. So they show the extract, the ethanol extract, show this kind anti-cancerogenic activity. So we proceeded along the study with the pomegranate seed, and we optimize the formulation of the extract, quindi the extraction process, in order to obtain a mixture that have this kind of activity, but we studied also the activity of anti-diabetic. So we use a different kind of cell, and we obtain the patent. And we are going to proceed to implement the study. So I will leave the floor to Professor Lucci, and I will continue to show you the nutraceutical purpose.
So, hi to everyone. Thank you, Deborah. Deborah talked us about some matrices like pomegranate, CFNL. Let's now focus again for a few minutes, a couple of minutes on olive oils and this byproduct. Olive oil, we tested also these fantastic fatty substances 1 hour ago, and is an icon, of course, of our country, of Italy, of the Mediterranean diet. It is recognized as the gold standard among all the edible oil. This is because of its peculiar chemical and health-promoting effect, because of many antioxidants, oleic acid, as Professor Sebeli told us this morning, and so on. However, we should be reminded that even the olive oil production arise a huge amount of byproducts. So the percentage is around 20 to 80%. Here you can see some, so we talk about stones, pomace, the watermeal, and olive leaves, etc. And it is important, of course, for the meal and for the food industries to manage these byproducts, because they represent a threat not only to the environment, but also an additional cost together with all the other wastes that are produced during the olive oil production for the meals and for the industries. That's why it is important to provide new solution to convert this type of byproducts into something new, as happened in the past, talking about feed, fertilizers, fuels, bricks, and so on. But we talk about the important properties of olive oil, and also the byproducts are really important for the food industries, because many of the compounds you can see here are characterized by bioactivity, so they have health-promoting properties. And and this, of course, can help to speed up a conversion to a circular economy approach, to speed up the consumption of sustainable food, of course, and also to exploit the nutritional properties of this byproduct. So just 2 examples that reporting the investigation that has been made in our university. The first one is the olive pomace. Olive pomace is a really interesting matrix because for enriching, for instance, conventional food, because it contains a lot of bioactive compound. The 2 most important one at the moment, considering the result I will show in a couple of seconds, is the phenolic compound. No? Phenolic compound, of course, this morning and this afternoon, we already discussed about this compound, so I will not spend time on that, but they have antioxidant, of course, anti-inflammatory properties, and they are involved in the prevention of many diseases like cancer, atherosclerosis, and cardiovascular disease. So what our university try to make is to exploit the possibility to add pomace for the enrichment of a widespread worldwide consumed bakery products like bread. And for doing that, of course, we need to face 2 main problems. The first one is the seasonality of the pomace. That's why in the experimental design, the pomace was stored for 6 months at 4 degrees and frozen, so at minus 18 degrees, to see if the antioxidant capacity and the phenolic profile were maintained during the storage period or not. And the result is that total phenolic content and in general the total antioxidant activity was preserved during the storage. So this is important for the application, for the incorporation of pomace to bread at food industry level. And the other point is, of course, the impact of the addition of this pomace from a rheological and technological point of view of a bakery product like bread. So different percentages were tested from 0 to 20%. A lot of analysis has been conducted, microbiological, chemical, etc., etc. I will not bore you with data and number, but the important outcomes are the ones you can see here. So the color changed a little only when adding 15 and 20%. There was a change in the volatile profile. The most important aspect is that there was an increase in the total phenolic content, of course, and the antioxidant capacity of the bread. So there was the possibility to functionalize, to enrich the bread with antioxidant compound starting from a byproduct, or better, a co-product, as the colleagues from Perugia told us this morning. Really short, another byproduct is olive leaves. There are also in this case many applications regarding the utilization of leaves extract for antioxidant, antimicrobial, biopackaging, as we discussed also before, etc. In this study, what was done is to test the ability of the olive leaf extract and two molecules that has been isolated from the olive leaf extract, which are oleacin and the aldehydic form of the oleuropein, on cell models related to severe and acute inflammatory process and pathogenesis related to the viral infection. And what was obtained in the result is that basically, as you can see, both olive oil extract and leaf extract and the molecule that has been isolated are able to modulate the release of two important molecules, which are the interleukin 6 and 8, and therefore to preserve and to prevent the inflammation properties, especially those ones related to infection, viral respiratory infection, and aging. So I finished. I just would like to acknowledge our research group, and one personal message that for me is really important is that we are not so far from a place where the 6th August 1945, the first atomic attack was perpetrated by humans. And during this week, we had the opportunity to visit Hiroshima Memorial Museum. And again, we saw the horrible crimes and sufferances that humans has perpetrated against other human beings, against women, children. And therefore, I think that is unacceptable and shameful to discuss again, despite it all, and especially during this day, about an increased risk of threat of nuclear risk. So we discuss about biodiversity. All of us are part of biodiversity. We need to learn to also respect human life and to respect human diversity. And therefore, my personal message that for me here in this important event is crucial is also not to any kind of wars, not to any kind of massive nuclear attack. We hope, a different world, a world of peace. Thank you so much.
Perfect. Good afternoon, everyone. First of all, I'd like to thank the Italian Ministry of University and Research, as well as the University of Macerata, for the opportunity to attend this conference. And we are very honored to be here. Within the context of BioNet project, the team from the University of Macerata has focused on the subject of urban agriculture, a field that has been the focal point of an extensive legal research conducted over several years by Macerata's researchers. And in line with the goals of a BioNet project, which focuses on biodiversity as a driver also for promoting well-being and the quality of life, our team, our research group, has analyzed the role that urban agriculture can play in promoting biodiversity and also in promoting an healthy aging. In particular, we analyzed whether and how this role of urban agriculture is recognized at the political and regulatory levels. We have selected this particular specific perspective which tries to put together three seamless, distinct areas of investigation, starting from the positive outcomes achieved in the context of another project. The project is Vitality, which involves all the universities of the Marche, Umbria, and also Abruzzo regions. This project is funded by the National Recovery and Resilience Plan and aims to create an ecosystem of innovation, sustainability, in order to promote, to foster the economy of the Central Italy. In the context of Vitality, the University of Macerata coordinates a specific spoke, the spoke number 7, that is named Safina. Safina stands for Smart Solution and educational program for anti-fragility and inclusivity. And in the spoke number 7, we had the opportunity to deepen the role of urban agriculture in fostering active aging. In fact, we have analyzed and studied a specific form of urban agriculture, urban gardening. Urban gardening means agricultural activities that are conducted by citizens, such as older adults, in urban or peri-urban areas for social purposes, not for business purposes. And in line with the other recent studies, our research in the context of Vitality, and more specifically in the context of Safina Spoke, has confirmed that urban gardening and more in general urban agriculture for older people promotes the well-being of participants, both physically and psychologically, fosters social interaction and community building, and facilitates access to food. Moreover, our research activities, after a very extensive, wide examination of the relevant policy and regulatory documents framework, has also outlined that the relationship between urban agriculture and active aging is now recognized and valued at both international and European and also national levels. And so, starting from these results, in the context within the BioNet project, firstly, we found that the trinomial relationship among urban agriculture, biodiversity, and healthy aging has been demonstrated to be effective and fruitful by several studies and experiences in cities worldwide. In fact, urban elderly farmers, urban agriculture practiced by elderly people really can contribute to biodiversity conservation in many ways. For example, by the cultivation of traditional varieties, by adopting sustainable practices, by the creation of urban microhabitats for pollinators, birds, small animals, and also by the transmission of ecological knowledge and other ways. And secondly, we studied whether this fruitful trinomial relationship among urban agriculture, biodiversity, and healthy aging is recognized at the political level, particularly at within the international and European context, as well as at the regulatory level, particularly at the national regional framework. Consequently, we have analyzed numerous policy and strategic documents concerning the 4 primary areas interested by urban agriculture, sustainable cities, food security, biodiversity, healthy aging, and we have therefore had the opportunity to study relevant documents such as those are listed in the slides, including the well-known UN Agenda 2030, the UN Urban Agenda, the UN Farm to Fork Strategy, the Milan Urban Food Policy Pact, the EU Biodiversity Strategy, and the UN Decade for Healthy Aging Action Plan, among others. Our analysis allows us to assert that the policy environment at both international and EU level underpins the recognition of a strategic role for elderly urban farmers in biodiversity conservation. And moreover, furthermore, this policy environment offers a lot of opportunities for fostering the role of urban agriculture in promoting biodiversity conservation and also in promoting healthy aging. And these outcomes are very, very relevant. These insights are very significant from a political and regulatory point of view, especially for policymakers and regulators at national and regional levels, as Dr. Serena Mariani will tell us soon. So I'll leave the floor to my colleague Serena Mariani for the second part of our presentation that is specifically dedicated to the national and regional framework.
Thank you, Professor Pamela Lattanzi. Good afternoon, and thank you for being here. As my colleague already mentioned, our analysis also focused on the Italian regulatory framework. So I want to start by saying that in Italy there is not a national strategy or a law addressing specifically urban agriculture. So our attention was dedicated to the analysis of these 2 legal instruments, law number 194 of 2015 on biodiversity, on the protection and enhancement of agricultural and food biodiversity, and on the analysis of the legislative decree number 29 of 2024, which was adopted last year, which deals with policies in favor of the elderly. The first legal instrument, as you can see here, clearly states that urban gardens are tools for biodiversity protection. So this role is clearly recognized in the Italian regulatory framework. And also it states that Italian regions may establish food and biodiversity communities to create urban gardens. A similar approach is adopted in the legislative decree, we also called it the Elderly Decree of 2024, which states that urban gardening is a means that encourages the active aging. And again, in this context, Italian regions may promote these initiatives also by adopting an intergenerational approach. So as you can see, Italian regions play a crucial role in promoting urban gardening initiatives for biodiversity and healthy aging, since they are the ones tasked with the implementation of such initiatives in this field. In the Marche region, the region where our analysis focused, which is also the region where the University of Macerata is based, we came to the conclusion that a crucial role has been played by urban policies and municipal regulations in regulating and promoting, encouraging this phenomenon. But the issue here is that every municipality adopted a different approach. Since we don't have a national strategy, we don't have a national law, everyone adopted different municipal regulations dealing with this phenomenon, with urban gardening in particular. So the consequence is that we have very dissimilar approaches at the local level to urban gardens. So, for example, in terms of objectives, what are the goals that are pursued by the local administrators? Who can participate in these initiatives? Only the elderly, or maybe schools, or even youngsters? The scale of the phenomenon, the conditions of use, whether it's organic agriculture or there are other specific conditions, and the resources, also financial resources dedicated to these activities, and who are the stakeholders involved? Maybe also nursing homes or schools and associations, businesses, etc. And for example, here in this table, you can see by way of illustration, an analysis that we carried out by studying the different municipal regulations of 5 Marche province cities, Pesaro, Ancona, Macerata, Fermo, and Ascoli Piceno, which have established urban gardens for specific purposes. And here you can see that, for example, there are municipalities that do not expressly state which is the purpose to be achieved. In other cases, the purpose is only social. In other ones, it's mostly environmental or cultural. So it depends. We can see a different approach here, and the same different approach that we can find in the participant requirements when it comes to the age threshold. So it depends. In some cases, urban gardens are dedicated only to elderly, so only citizens who have reached at least a certain age, 60 years or other different ages, can participate. In other cases, even youngsters. In other cases, it's not indicated. So everyone can participate, can take part. So this shows, in a very brief way, the different approaches that are adopted at the local level. But we decided to also take into consideration 2 specific case studies that we found in our region, because they show that urban gardening, urban agriculture in general, can play a crucial role both in healthy aging and biodiversity preservation. Because sometimes when we deal with urban gardening, the approach that is used is only one-to-one. So urban gardening for biodiversity conservation or urban gardening for healthy aging. In this case, this experience combines these 3 elements. So urban gardening, healthy aging, and biodiversity conservation. The first case study are the organic gardens in Ripa Bianca Nature Reserve, which is based in the town of Iesi, the province of Ancona. In this case, organic gardens are placed within this nature reserve, and there is an initiative which is called Grandpa Grows. So only senior citizens can apply for these urban gardens, but they must, expressly written in the regulation, they must share their knowledge with local schools, with youngsters that are interested, with university students, etc. So anyone can really get knowledge from this experience. So there is an interesting transfer of knowledge. And as I said, this is an organic garden that aims to promote biodiversity while encouraging healthy aging, so adopting an intergenerational approach. Also, the Ancescao Urban Gardens. Ancescao is an Italian association for elderly. Ancescao manages a lot of gardens in Italy, municipal gardens, so they are the one managing the gardens that are owned by the municipality. And in the Marche regions, they manage almost 60 urban gardens. And in their case, they want to promote mainly social cohesion among the elderly. They want to promote a healthy lifestyle for the elderly, but at the same time, as is written in their statute, they want to promote the greening of the cities. They want to promote biodiversity. They want to promote a more healthy urban environment. So these two examples show that it's possible to look at urban gardening as a tool that promotes jointly biodiversity conservation and healthy aging. And coming to the conclusions, this research led us to believe that the policy environment at both the international and EU levels offers opportunities to strengthen the role that urban agriculture, especially urban gardening, can play in fostering biodiversity conservation and healthy aging. And at the same time, the relationships between urban agriculture and biodiversity, and as well as urban agriculture and healthy aging, are recognized and promoted by Italian policy and lawmakers, as we saw in the analysis of the two legal instruments. However, there are a few issues. First of all, there is a lack of a strategic approach to urban agriculture, which led to the adoption of fragmented initiatives, very heterogeneous actions. We believe that bottom-up actions at the local level must be combined with a top-down approach that helps local governments, local administrators, in adopting policies that are tailored to their effective needs. At the same time, there is a problem of lack of resources, financial resources especially, because both the two laws that we analyzed before said that these initiatives shall be carried out by Italian regions, but without any burdens on public finance. So there are no finances specifically dedicated to the adoption of such initiatives. And on a final note, we believe that it's important to strengthen the role of urban gardening, urban agriculture in general, as a tool that can promote jointly biodiversity conservation and healthy aging. And how can we do that? A solution could be the recognition of the role of urban senior gardeners as, we can say, stewardess, custodians of urban biodiversity, by transferring their knowledge to younger generations, by adopting environmentally sound practices, and promoting the urban greening. In this way, we can recognize the value at the environmental and social level of what they are doing, and so ultimately we can enhance their role, their positive, the benefits for the common goods. So thank you very much for your attention.
Good afternoon, everyone. I'm Lilia Neri from the University of Teramo, and today I will talk about saffron. Saffron, which I don't know if you already know, but basically is a spice represented by dried stigmas of the flower of Crocus sativus. And this spice is called the red gold. Why? Because it's very, very expensive. Let's think that 1 kilogram of saffron can cost up to 30,000 euro. Why? Because under the production of saffron, there's an intense human labor. The origin of saffron dates back to the Bronze Age. We know this from this fresco that was found in Santorini, in Greece, from the Minoan civilization. And today, the World Saffron and the Crocus sativus collection can count up to 243 accessions that comes from different countries. The main producers are for sure Iran, followed by India, Morocco, and then we have Spain, Greece, and Italy. In our country, we can boast three important productions with three different products. The zafferano or saffron from San Gimignano, saffron from Sardinia, and then we have the zafferano saffron from L'Aquila. And since I come from the Abruzzo region, where L'Aquila is, let me spend a few words in relation to this specific product. It has very high quality, which depends on strict regulation rules adopted for the production of the spice, and also due to the peculiar pedoclimatic conditions that we have in this area of Abruzzo, in particular in the Navelli Plateau. For this territory, saffron actually is a strategic cultivation. In fact, is of course a source of income, but the cultivation of this spice, of Crocus sativus, and then the production of saffron allows the maintenance of the biodiversity of these territories. Now I would like to describe which is the composition saffron, which are the factors that affect the saffron quality, and how we can valorize this spice. Saffron is composed by macro and micronutrients. However, the peculiar properties of this spice come from these secondary metabolites, crosins and crocetin, which are apocarotenoids, so they are soluble in water and are responsible for the red coloring power of the spice. And then we have picocrosin and the safranal, which are responsible respectively of the bitter taste and of saffron aroma. We have also other minor compounds, and all these make saffron a very precious ingredient for the food sector, the cosmetic sector, but also for the nutra and pharmaceutical ones. This is why it has different functional and also techno-functional properties. In fact, as you can see, this spice presents several therapeutic effects that have been shown both by in vitro and clinical studies. So the quality of saffron is strictly dependent on the content of the compounds that we have seen before, and in particular on the content of crocin, pacocrosin, and safranal. These specific compounds determine also the classification according to the ISO standard of saffron in different quality categories. The factors that affect the quality are several. Of course, we have varietal and pedoclimatic factors, agronomic and post-aster factors. For example, it's very, very important to stabilize the stigmas after harvesting. And then we have process factors and the storage. In particular, it's very important to give saffron the time to age. Among the process-related factors, the most crucial phase is drying. Why? Because drying stabilizes the spice from the enzymatic and microbiological point of view, but also it promotes different chemical and enzymatic reactions and physical and structural changes that are very important in order to allow also the extractability of bioactive compounds. However, this process can also determine the degradation of all the compounds we were mentioning before. That's why in the last years the research was strictly focused on the identification of, for example, the optimal temperature and times to dry the stigmas. And also in the evaluation of new drying technologies. And this is something that we have done also in Teramo, in particular within the research activities developed for the Polis project. The Polis project was a project funded by the Abruzzo region. We compared the effect given by the by toasting, which is the drying method applied for the production of saffron from L'Aquila, with freeze drying and air drying in temperature control conditions. Based on the results that we obtain, but also considering what has been reported in literature, what can we summarize? Among the conventional drying processes, for sure, toasting is the best one. But if we consider also the use of more advanced technologies, that ones that give the best results in terms of quality are freeze drying, microwave drying, and vacuum drying. Let's see now which can be some process strategies to further valorize this spice. For reasons related to the short time I have today, I want to highlight this specific process that we studied in Teramo that combine the use of pulsed electric field with drying. Very, very in brief, PEF is a technology that consists in the application of short pulses of electricity to the plant tissue. And optimizing the process conditions is possible in this way to determine the electroporation of cell membranes. So we perform the PEF and then we proceeded with the drying process. After PEF, actually we had some loss by leasing of water-soluble compounds. But besides this, after drying and then aging, we were able to obtain saffron with high quality, classified in the first category, as well was obtained for the saffron conventionally produced. Other strategies that in this case are capable to valorize the saffron extracts for the production of saffron-based ingredients are the microencapsulation technologies. What we do by microencapsulation, we take an extract rich, concentrated in bioactive compounds, we add a wall material, a carrier, and then by using different technologies, methods, we are able to entrap the bioactive compounds within this wall material, and this allows for the protection of sensitive compounds such as, for example, crosins. But we also are able, optimizing the processes, to control the release of saffron bioactive compounds and also to enhance their bioavailability. And I want to conclude just with this slide where are summarized some of the microencapsulation technologies that we are investigating in our university that allows for the production of ingredients with different morphologies, with different physical states. As for example, we can produce solid microparticles by using the spray drying or the ball milling technology, or we can produce by dripping and ionic gelation alginate beads that you can see here, where we have the wall material surrounding a core where the bioactive compounds are concentrated. So, which are the messages I would like you to take home with you? Saffron is a spice with technofunctional and bioactive properties, supporting its use in the food, cosmetic, and also pharmaceutical sectors. Saffron quality, however, is strictly dependent on process and storage factors. The use of advanced technologies can help us to valorize this spice and also to valorize saffron-based ingredients. And finally, basically, if we valorize saffron as an ingredient, we are also able to promote the cultivation of Crocus sativus, and so to empower local economies maintaining genetic biodiversity and protecting naturalistic landscapes. Thank you for the attention. I would like also to thank all the working team from the University of Teramo.
Okay. So good afternoon to everyone. I'm Gianni Sagratini. I come from University of Camerino. Thank you very much to the organizing committee. Thank you very much to the organizers, to the University of Urbino for this possibility to speak, to present you some of our research projects that actually we have in our university, in our research group, that are concentrated on food waste, in particular in two different supply chains. One is the supply chains of fishing, and the other is the supply chain of wine. And the common characteristics of these two projects is that we are trying to transform a food waste in an added value by obtaining a nutraceutical product. So first of all, sustainability is a very important word, and all the time that we speak about sustainability, we have to remember that sustainability is not environmental, or only environmental sustainability. and not only economically sustainability, but also social sustainability. So if we take a look to some number in particular, if we take a look to the Food Waste Index report of 2021 by United Nations Environment Programme, we see that each year 931 million tons of food waste were produced across all the entire food chain. So it's a very big number. And this number represents close to 17% of waste produced in the food chain, and from 45 to 60% of waste occurs during the industrial processing and post-harvest operations. In particular, if we take into account some food chains, as for example, beverage industry, we have to note that for coffee, for tea, for beer, for wine, food waste of these supply chains are destined to animal feed. So they are not used for the production of an added value as, for example, nutraceuticals or functional foods, but the first direction is this. So we think that if we take a look to the agri-food system, in particular to plant-based byproduct, and if we put our attention on fruits, cereals, in general, vegetables, we have to highlight that they are rich, also waste, in many kind of bioactive substances, macronutrients, micronutrients, phytosterols, polyunsaturated fatty acids, and so on. So there is an important part of this waste that could be used for the production of functional foods, for example, or healthy products such as cosmetic and also nutraceutical. If we think to the total biomass derived waste, we can divide this important biomass into different kinds. The first is related to the lignocellulosic agricultural residues that is rich, especially in polysaccharides molecules, such as cellulose, hemicellulose, and so on. And the most important use of this biomass is, for example, the use as biofuel, or this biomass has been used for the production of biomaterials. While there is another kind of waste, in particular food wastes, that is also rich in polysaccharides, such as cellulose, hemicellulose, but is also rich in bioactive compounds, as I said before, flavonoids, tannins, polyphenols, that can be used for the preparation, for the formulation of nutraceuticals by using different kind of extraction techniques that you see in the slide, starting from the most common, most classical techniques, such as solid-liquid extraction, liquid-liquid, so conventional extraction techniques, passing through the microwaves, the use of microwaves, ultrasound that are able to generate cavitation phenomena, or mechanochemical extraction that don't use, for example, solvent or enzymatic extraction. So there are many kinds of extraction techniques that can be used for the extraction and then formulation and preparation and formulation of nutraceuticals. But what is a nutraceutical? So first of all, we have to say that this word is not regulated. So there is not a specific regulation of nutraceuticals, and this word was coined in 1990 by the pharmacologist Stefan De Felice, who merged the terms nutrition and pharmaceutical. And with this term now we mean food components, bioactive molecules, ingredients, in general foods that have a healthy, a positive effect on human health. Commonly, if we speak, for example, with medician or nutritionist, a nutraceutical is a pill that is rich, that contains an extract rich in bioactives at high concentration, more that normally we can find in food. So before to present you two of our research projects in this field, I want say you that there are many applications, many kind of applications that describe it as the process that starting from a waste, in this case, for example, I'm speaking about waste or byproduct of wine industry. This chains generate from 20 to 30% of waste. So in this case, also the numbers are very high. Each year, there are 13 million tons of grape pomace that are produced worldwide. So starting from a grape pomace is possible to, after extraction, formulation, using, for example, the microencapsulation spray dryer that my colleague showed you before me, it's possible to produce a nutraceutical rich in many of the molecules that you can see in the right part of the slide, so phenolic compounds as flavonoids or organic acids and so on. And another interesting application, in my opinion, take into account the fishing waste. The colleagues from University of Genoa in this application, in this work, they produce, starting from tuna, so the waste of tuna or byproduct of tuna, marine hydrolysates. So they are able to obtain bioactive peptides that are active because, for example, they have antioxidant capacity. They showed antioxidant capacity. They showed anti-hypertensive activity. So also fish waste is interesting to investigate. And now I go to present the first of our project. This is a print project. The acronym is Vita di Waste. This is on the left part of the slide. There is the partnership. We are the PI, the leader of the project, and the aim of this project is to produce an extract rich in vitamin vitamin D3, not only vitamin D3, but also other lipophilic substances, as for example fatty acids, polyunsaturated fatty acids, starting from fish waste. So fish that is not useful for the market of fish because the size is not okay for the market. So after the extraction, formulation, and finally clinical study for the determination of the bioavailability and clinical equivalence, I hope that we will be able to have this nutraceutical. So why vitamin D? Because vitamin D is probably one of the most substance molecule lacking in the population. We know that 40% of European population is lacking in vitamin D. And this Professor Windhouse, has been the researcher that firstly discovered the two different structures of vitamin D3, vitamin D. The first form is vitamin D2, that is named ergocalciferol, present just in vegetable food, such as mushrooms. And the second is vitamin D3, present in animal foods, cholecalciferol. So he won the Nobel Prize in Chemistry in 1928. So starting from the fish waste, CNR Irbin of Ancona is one of our partners. We focused our attention on mackerel, anchovies, sardine, mullet, eggs. We are able to do the sample preparation. After the sample preparation, they homogenize sample, they freeze dry it, And INEA, that is another partner, is able to extract from this waste by using this kind of technique that is a supercritical fluid extraction by using carbon dioxide, so without solvent, without liquid solvent, so it's a green technique. They have been able to produce an extract that has been studied and quantified for the presence of vitamin D3. Another partner, CREA, developed a system for the classification, the description by a code language and code FOODEX tool by using FTIR ATR, a system that said us which is the part of the fish, which is the concentration of vitamin D3 in the analyzed part of the fish. So in our laboratory, we studied also other kind of extraction techniques, such as ultrasound-assisted extraction, and we set up the HPLC methodology for the analysis of vitamin D3, also vitamin D2, the precursor of vitamin D3, that is the 7-dehydrocholesterol, and some isomers of vitamin D3, that is dehydrotachisterol. Another important study that we did in this project is the biotransformation of 7-dehydrocholesterol in vitamin D3 through the irradiation of this extract. In fact, if you see the data related to anchovies or sardine, we are able to enhance the concentration of vitamin D3 up to 10 times after the irradiation with UV radiation at 312 nanometers. So finally, University of Piemonte Orientale did the microencapsulation, so the spray dryer process for obtaining the powder that after the encapsulation will be studied by University of Bologna in a clinical study for comparing, for checking if this extract is able to function as a commercial nutraceutical that contains vitamin D. So these are some of our publications related to this project. And the second project that I want to present you is a European project, is a live project. This is the partnership. The leader, the PI is Natural Development Group, that is an Italian industry. And the aim of this project, the aims of this project are two. So the first is to test, to use biopesticides that contains essential oil instead of conventional pesticides in the wine industry. So in the supply, in the chains that is able to produce wine. And the second aim is to recover and to extract bioactive molecules from grape canes. In particular, we have concentrated our attention on resveratrol, trans-resveratrol, and transviniferin, because in the grape canes there is a very high concentration of these compounds that is close to some gram a kilogram. So we are working because we are at the second year. We have developed the methodologies of extraction and quantification. And with the second project that I shortly presented you, I want just say that it's possible to transform a waste in an added value product, such as a nutraceutical. There are important, fundamental, and critical issues. I want to underline that it's one of the most critical issue, in my opinion, is ethics committee or ethical committee, because we have to test the activity of this nutraceutical in a clinical study. And in conclusion, there is another important aspect that I want to underline, that for improving this kind of we should improve the direct use of agro-industrial and domestic wastes as feedstock. So finally, I want to thank all my research group and people involved in this project. And just as a conclusion, I want to thank Paolo for the consideration that he did before, because I totally agree with him. So Expo is against war, and I think that is the most strong message that we can say to everybody. Thank you.
Thank you very much to all the colleagues of the universities of Ancona, Macerata, Teramo, and Camerino for this very valuable insight on the role of chemical factors that have an influence on health. So I think the topic of nutraceutics will be very, very relevant in the future. And we go on with the last series of presentation. So I invite Elena Viganò from the University of Urbino, Maria Benedetta Mattei from the University of L'Aquila, Elisabetta Salimei from the University of Molise, and Fabiano Compagnucci from the Gran Sasso Science Institute. The session will be about biodiversity and sustainability in the agri-food industry, so another very relevant topic for which we are ready to listen. Thank you.
Thank you, Fabio, for your introduction. Good afternoon, everyone. Thank you to being here today with us. A special thanks to Ministero of Università della Ricerca, Expo 2025, and a special thank to everyone who has worked hard to organize this meeting here at Expo and in Italy. Now, I talk... I talk about the link between organic farming and protection of biodiversity, focusing on the case of Marche Organic District, that is a project aimed to improve sustainability of territorial system. My presentation includes findings from research conducted in our department, the Department of Economics, Society and Politics, with colleagues from many disciplines, as well as the stakeholders of our region. And I would like to express my gratitude for their professionalism, their enthusiasm, their support. It's a biodiverse group, very, very interesting. Let's begin with the crucial link between organic farming and biodiversity. This connection is vital because we have surpassed 6 of 9 of the boundary system of our Earth. That means that we are operating outside of a safe ecological space for humanity. For the biodiversity, we have to discuss the causes, the principal drivers, including climate change, that are responsible for this loss of biodiversity. Climate change, I said, but also the global food system, and in particular agriculture, industrial agriculture, and the cheaper food paradigm that are destroy the many natural resources during the conversion of natural ecosystem for crop production. In particular, the use of chemical inputs, GMOs, antibiotics, has been the principal cause of habitat loss. And a dramatic consequence of biodiversity, I don't know, is stopped. Climate change, no, ma is the decline in ecosystem services, like pollination, like soil fertility, which are essential for the life in our planet, in our home. So we have to shown the principal consequence of this situation, and focusing on the principal positive aspect of organic farming. First of all, restoration and protection of biodiversity, but also many other aspects, maintenance of soil fertility, reduction of greenhouse gas emission, human health protection. And these positive effects come from a system very complex, the interaction between structural factor, the circle in yellow with diverse crop and livestock rotation in the center, and the tactical strategies, including, for example, biological controls or physical methods, etc., that improve many aspects of ecosystem. More in general, it's important to note that organic farming follows a holistic approach, and managing complex systems at several levels, a single production processes, the entire farm and its surrounding landscape as one living system. In this context, in these systems, complexity creates balance, and diversity is essential for stability. So we have many positive aspects for the environment, but there is also many important aspects in terms of economic aspect, as job creation, attractiveness for young people, and growing of demand of organic production. And so is important to improve the production processes, and to facilitate the process of conversion to organic farming, in according to the content of communication of the European Commission from a farm to fork strategy that define an objective of at least 25% of the EU's agricultural land under organic farming by 2030. To improve the conversion to organic farming, we need to explore drivers, factors hindering or promoting this conversion. So in our department, we study the innovative capacity of farmers, about the adoption of organic farming, and also the adopting of specific digital tool that farmers can use to improve the transition, the ecological transition, and the business management. Our research shows that there are many important characteristics hindering or promoting adoption of innovation, but there is an aspect particularly important, that is cooperation and integration. So it means that to achieve technological innovation in production processes and farm management, a cultural and organizational innovation is needed. In this context, in 2023, the Marche Organic District was born. Marche Organic District was born in a region, Marche, that has already exceeded the target of 25% of land under organic farming. A region that is one of the cradles of Italian organic farming, thanks to entrepreneurs such as Gino Girolomoni, who many decades ago believed in a production model alternative, radically different from industrial agriculture. Marche Organic District was promoted by several organizations, CIA, Coldiretti, Copagri, in collaboration with main agriculture organizations. And there are 2,003% operators in many supply chains, and 90,000 hectares distributed across over 95% of municipalities of Marche. For this reason, Marche Organic District in this period is the second largest organic district in Italy after Sardinia. The district's mission can be summarized in four keywords: research and innovation, sustainable tourism, internationalization, and regional development. In the first case, district promotes technological innovation, but above all, organizational innovation, promoting integration and cooperation. But Marche Organic District promotes also rural tourism, a model of rural tourism aligned with the IFOM principle of health, ecology, fairness, and care, and promotes organic food in international and national market. For our socio-economic system, Marche Organic District creates jobs, and this is particularly important because stimulate growth in areas that are at risk to the population. And more in general, it promotes a healthy and sustainable lifestyle. So, some conclusions. As we look to the future, I think that adopting organic farming is a vital choice for the sustainability of our system, of our agri-food system. But the Marche Organic region is more than that, because it can integrate this production model with other activities, other economic activities, as sustainable tourism, to promote economic development in our regions, combining tradition and innovation. Technological innovation, but also social innovation to change behaviors and value in line with environmental, social, and economic sustainability. To promote this project is very important the role of institution, because organic district, but in general organic farming, need a support from institution, regional and national institution. As we have demonstrated in our research, exists a broad consensus among Italian citizens for policies that support farms that are committed for environmental sustainability. There is a great acceptability of the CAP, and this is an aspect to be in consideration, because a request for a policy that improve the impact on environmental or natural resources is very important. And personally, we say that difference creates balance, and as slogans of Distretto Biologico Marche 6, della biodiversità che ci unisce, Biodiversity Unites Us, I think that Marche Organic District is an example when firm cities and institutions, each of us within our own sphere of competence, can working together to build a future based on tutela degli ecosistemi, cuidado della salute, economic prosperity, justice sociale, inspired by the principle of libertà kan io tu heiwa. Arigato.
Okay, thank you again. This afternoon I will talk about different aspects of sustainability, so how we can advance sustainable agriculture by reducing the input of synthetic phytochemicals, replacing them with natural alternatives such as beneficial microorganisms and biostimulants derived from microalgae. So this is an approach that has the aim to reduce the use of phytochemicals that have growing environmental impact and drawbacks, and also exploring the biodiversity of microorganisms and different sources of biostimulants that we can find in nature. So there are many different biostimulant sources, for example, algal-based, microorganism-based, or other elicitors that can be, for example, carbohydrates that you can derive from wastes, for example, from agricultural wastes, or lipid-based, amino acid-based, and so on. So they, differently from the synthetic phytochemicals, they have a different mode of action because, for example, they act by stimulating natural processes in the plant. And they have different mechanisms. Usually they can improve, for example, nutrient absorption, water availability, so they can influence the xylem or the root system. And in general, they can enhance plant growth and plant resistance to abiotic and biotic stresses. But they do so by helping the plant to reinforce its own defenses. So all these mechanisms are complementary, and they can be studied, of course, in depth, and that's what some of the projects that we are doing are focused on. So the first project I would like to mention is a project funded by Next Generation EU Plant, and it's led by the Giuseppe Ianiri from the University of Molise, and in partnership with Dr. Benedetti from the University of L'Aquila. And this is focused on the mechanism of action of a biocontrol agent that is Papiliotrema terrestris. There is a yeast that shows great potential as a biocontrol agent against fungal pathogens. So the aim of the project is to study the molecular mode of action, including how this yeast can scavenge nutrient, provide resistance to oxidative stress, and induce the defenses of the plant itself. And so it can provide an eco-friendly alternative to chemical pesticides. Another project also funded with the PRIN Next Generation EU plan is a project that I lead in partnership with the University of Naples. And this project is called microalgae-based biostimulants to mitigate botrytis infection in tomato, Altritom, that is focused on a very important pathogen. Botrytis cinerea is the causal agent of gray mold in many crops, and for example, tomato is one of them. And so the idea is to develop alternatives to pesticides, exploring the biodiversity of microalgae. So we have been comparing different microalgae from also extreme environments, such as those that are growing in hot springs. And we want to identify compounds that can elicit, that act as stimulators of plant defenses. This is a test on a model plant that is Arabidopsis thaliana. It's a plant that we use in the laboratory. And you can see that we tried different algal strains, and there is one strain, A01, that can strongly protect the plant. So if you pre-treat the plant with water extract from this microalgae, the plant is more resistant to botrytis infection. And then, in collaboration with the University of Naples Federico II, we did the same trial on tomato plants. And also in this case, the same extract could protect two different genotypes of tomato, but not the third genotype. So these are three different varieties of tomatoes. And this seems very interesting because it means that the biostimulant is able to activate specific pathways that are cultivar dependent, so that you have to adjust the use of biostimulant to specific genotypes. So one size does not fit all, and so the interaction can be actually strain cultivar specific. Then the next and last two projects are two projects led by Professor Marica Pellegrini, a colleague at the University of L'Aquila. The first one is called InnoWine, and it's aimed to reduce the input of copper and other technical inputs in organic and biodynamic vineyards. So the objective is to develop the used microorganisms, in this case, that are able to improve plant growth and allow to limit copper significantly, and so decrease the chemical input. The second project, PROSA, Innovative Processes for Productivity Improvement, is also based on growth-promoting bacteria that can, in this case, help the absorption of phosphorus, because there is a compound derived by these bacteria that can solubilize the forms of phosphorus that are of phosphate that are not available, and so make them more bioavailable and more suitable for plant absorption. And so also in this case, the aim is to significantly decrease the use of agrochemicals. So I would like to conclude by saying that biostimulants are increasingly recognized as a real alternative to traditional agrochemical. The projects that I presented are some ongoing projects that testify that this use of natural alternatives can be explored and applied in agriculture, and that these nature-based, biodiversity-based strategies can respond to environmental challenges. And of course, to fully realize this potential, we must invest in research, collaborative research and innovation, and also support all these efforts through policy frameworks that can accelerate the adoption of these sustainable practices. Thank you for your attention, and I thank the audience and the organizers again for this organization.
Good afternoon. I'd like to thank the Ministry of the Research and University and the BioNet leader for the amazing opportunity to be here. This presentation deals with research now in progress at the University of Molise. Let me give some tips on this smaller region, Molise region, which is the belly, is called the belly of Italy because its location. And the topography of the region is mainly mountainous. 55% is covered by Apennine mountains and 40% by hills. In these inner areas, the origin of animal husbandry is very ancient, as you can see from this picture from an archaeological site very close to Campobasso, and which is related to transhumance, the intangible cultural heritage of humanity. Across the century, the socio-economic of this area developed around animal husbandry, and people still enjoy the huge variety of local traditional food from animals, most of them with health-promoting properties. However, these inner areas are mainly characterized by volcanic soil with high seismic hazard. And so we assist in when the occurrence of other triggering factors such as intense rainfalls, we have high risks of hydrogeological risk, and we assist to land abandonment and degradation, depopulation and aging, which is a great concern for the Mediterranean Inner District. So, for the conservation of these fragile ecosystems is essential to provide benefits. The system has to provide benefits for the survival. And this is the topic of 5 projects carried out at my department, funded by the Italian Recovery and Resilience Plan. And the common thread of the project consists in research-based innovation as a key for a feasible, sustainable livestock farming system in inner areas, also related with the products with health-promoting properties. The animal genetic resources represent a crucial point in this topic. And the first project, Cometa project, deals with a wide multi-omic profiling approach on the response, the mutation for the resilient response of sheep, cows, and buffalo, local breed, of course, to environmental conditions such as heat stress and management of the animals. The project proposes genetic, epigenetic, and metabolic variations, the study, of animals raised in Center-South Italy. And the exploitation of the advances of knowledge on mutation can produce, as a result, the implementation of these adaptive mechanism in the farming system of inner areas, so that the genetic selection of the animals will be redirected for a sustainable animal husbandry. And then in this at the same time, the health status of the animals, because of the selection, will be enhanced, and in the same time, the animal diversity preservation will be increased with a potential recovery of the socio-economic role of farming in these areas. The second project deals with sheep diversity in Center-South Italy, and this project deals with the genomic resilience background in Mediterranean sheep breeds. And the approach is highlight genomic regions associated with environmental conditions such as pedoclimatic condition, identify the resilience indicators of by the means of machine learning and multivariate approach. At the end, more in-depth analysis compare the genotype data of local sheep with other breeds. I'm sorry. From this project, From this project, we already have some results. Milk, infrared spectra milk from 2 breeds reared in different altimetric zones like Valle del Belice and Sarda has been successfully discriminated by artificial intelligence tools. Then the footprint of genomic regions and genes potentially associated with this adaptation has been defined, and using single nucleotide polymorphisms, the local breeds has been compared to cold adaptive breeds. And moving to the technology of the livestock farming in Center-South Italy, the Teama project deals with precision technology involved implemented in the sheep farming of inner marginal areas, sheep raised in extensive system. The main aim is to improve the quality of traditional foods, local foods, milk, meat, and also non-food like wool. We are talking about sheep. And ecosystem services from this innovative farming system are explored, and the increased sector competitiveness related to the innovation will generate will improve, will sustain the generational change of the farmers. In brief, both climate changes and the geographical gaps will be challenged by the use of digital technology implemented in the managing system for grazing animals. In this way, besides achieving a lighter workload for transhumance and sheep farming, we have a higher control on the use of natural pasture and better management of the animals with a positive relapse on milk, meat, and wool production in terms of production, which is important, and quality of the production. So also in this way, economy and society of rural areas will improve and with a positive effect on the revitalization of the rural areas. Next project is devoted to a more intensive farming system, always related to sheep, and proposes feeding protocols based on the circular economy strategy in sheep farming, always in inner marginal areas. More in details, byproducts products from local wineries like grape mark and olive oil industries like olive pâté are introduced in the traditional diet of sheep, and the effects are studied on health, welfare, and productivity, efficiency of the animals, but also on the nutritional and sensorial quality of milk, meat, and dairy products. The effects of this strategy, green strategy, is also studied on the impact on enteric methane emissions. We don't forget that they are ruminants, they produce methane, and also the environmental impact is monitored by the mean of the global warming potential along all the life cycle of the animals. And the proposed strategies then are expected to promote the transfer of nutraceutical compounds from these byproducts into milk and meat. Maybe they don't need a lot of processing and very expensive. And this simple waste recycling from the agro-industry is, of course, positive. And the strategy proposes increase of farm competitiveness across the economic, environmental, and social dimension. And finally, Sune Kumar project emphasizes the interaction among environment, equine farming system, and research based of innovations to be implemented in this other extensive farming system devoted to horses and carried out in marginal areas of Apennines of value in terms of landscape and culture. The project, by the means of digital tools for animal tracking, also assessed by the drone technology, aims to monitor the land use and the nutrition of equine, but also related to health and welfare, of course, but also to the transfer of compounds from pasture to equine metabolism and meat quality. The project also includes the study of environmental impacts by the mean of global warming potential and also carbon sequestration, because we have to remind that pasture can be good carbon sink, which is good, but if the pasture is not very well management, soil can be a carbon source, which is not good. So management of pasture is very important. And the project also considers a survey on the stakeholders' perception on livestock-based productions, especially equine production, and immaterial and material benefits for the inner marginal areas. A peculiarity of the project is the active involvement of young farmers in defining the best practices to be implemented in the farming system for a feasible, future-proof farming system in marginal areas for the future. So results are expected to increase interest in the equine farming, not only for tourism or work, but also for producing food, maybe with added nutritional value. And also we are expected to protect biodiversity and also the use of the landscape for the future generations. And at the end, in conclusion, advances of knowledge and implemented sustainable innovation in normal traditional farming system of inner areas are crucial in maintaining ecosystem services provided by animals in these fragile areas. And these services are particularly important for the next generation because they provide safeguard of the landscape and preserve traditional culture, including typical food with added nutritional value. I thank you very much for your attention.
So good afternoon. I'm Fabiano Compagnucci from GSSI L'Aquila. Thank you for having invited me, and thank you for having organized such an interesting event, and thank you for having resisted until now for our Japanese friends. So I will be very, very brief, and yes, basically I'm going to share with you two interesting stories about two specific cultivar coming from the Abruzzo region, which is the region where I work, and why these two stories are so important, in my opinion. They are so important because, of course, you today, several of you explained the importance of this kind of cultivar in terms of biodiversity. Some of us also highlighted the importance for rural and inner areas communities. So this kind of cultivar can actually play an important role in fostering the so-called resilience and resistance of these communities, which have been experiencing a sort of slow burn process over the time. So basically they experience the process of socioeconomic marginalization, and we know that at the moment in Europe we have more or less 100 million people living in marginal areas. If we focus on Italy, we know that in Italy we are more or less 60 million of people, and 1/4 of these people live in inner areas, so 12 million of people, covering an area which the distinction is the 60% of national territory, and more or less roughly the half of municipalities present in Italy. So you can understand how important the issue of inner areas and marginal area represent for Italy and for European countries, to the extent that in Italy we have a specific strategy in order to respond to this depopulation process, which is called the National Strategy for Inner Areas. And the two cultivar I'm going to present you can be included within this policy, which try to stimulate local development processes, as well as the provision of the essential services which unfortunately are no more supplied in this area. So the two case studies are, as I told you, from the Abruzzo region. The first one is the Altino sweet pepper, and the second one is related to the two kinds of grapes which are always present in the same area of the Abruzzo region in the province of Chieti. So the Vedovella of Petralucente and the Nero Antico of Petralucente. Petralucente is the ancient name of Gesupalena. So it is also interesting because these two kinds of cultivar are present in an area which has an important institutional history, meaning that in that territory, since 30 years ago, there are different actors and stakeholders, public and private, which are cooperating, and now we are collecting the results of this important institutional cooperation. About the Altino sweet pepper, so basically, yes, it is produced in these 7 municipalities in the province of Chieti. What is interesting is that in the turn of the new millennium, it was a kind of cultivar which was disappearing. It was just used for self-consumption, while on the contrary, because of an animal spirit of a former mayor of Altino, he decided that it couldn't be the end of this product. And so with all the community of Altino, I'm speaking of a municipality of about 1,300 people. So basically they created a community project. And this community project involved also universities, agricultural research centers, and basically the sweet pepper of Altino became a slow food presidium. So it is now used in important restaurant in Milan and in Rome, for instance. But what is more important is the outcomes in terms of local communities. In this case, in terms of identity. And please don't think identity like closure. The sweet pepper of Altino actually comes from the migration from the Balkans during the 15th century. So Slavic people coming from the Balkans to Italy in the province of Chieti, and they took this kind of product, so which is also similar to the paprika. In fact, in the province of Altino, they used to dry this pepper and to use in powder. So you can understand that identity is not closure. We should intend it as a dynamic process, since these are not our product. But what is more interesting in terms of local community is the fact that each year, since 2009, if I'm not wrong, there is the palio of the sweet pepper of Altino. So it's a sort of culinary competition in which the different settlements of Altino compete in terms of dishes, of different menu. And this implied also a research related to the local housekeeper in order to find out what were the tradition, how they cook them, and so on. So there was an important, I'm going to say, recover of self-identity and self-consciousness, and the importance, the values they carried out, because we must remember that if the inner areas are not in health, and they are usually located in the mountain areas, also the places in the valley will suffer from very bad condition. So this is the first one, and the second one, on the contrary, is an incredible story. So I'm really fascinated by this story, which conjugate resistance and resilience. Why resistance? Because during the Second World War, there was a massacre in Gesopalena perpetrated by the Nazi soldiers. There were 2 Nazi soldiers which attempted to steal 2 pigs from a farmer. And you can understand that in that period, 2 pigs, it was life or death. So basically the farmer killed the 2 soldiers, and so the Nazi soldiers decided that 40 people coming from that community should have been killed. So actually 38 people were killed with a bomb within a home, but there were 2 survivors. One of those survivors is Giuseppe D'Amico. Giuseppe D'Amico participated to the reconstruction of the city of Gesopalena, which was completely razed by Nazis before leaving, and also to reconstruct his vineyard. And in this vineyard, there was a kind of grapes, a kind of grape which was completely unknown. It is not Sangiovese, it is not Montepulciano, and the grandson of Giuseppe D'Amico, with the help of university and so on, find out that it's a product which comes only from Gesopalena. So it's a variety you cannot find in other places. And I tasted, and it's more like the French wine, but okay, that's another personal experience. And here again, so this is important because they each year pay tribute to the person, to the citizen which were killed in the Sant'Agata massacre. And this is another element which foster their identity. They are also like the example of the Marche region. They are creating an organic biodistrict. And all these elements are important because together they actually can make the difference, along with the fact that the national state has to provide essential services. Otherwise, it is impossible for the person living in places where there is no education, there are no hospitals, and there are no public transport. So this said that actually it is not that this place can rely only on this cultivar, of course, but it's a sort of another element, a further tool in order to, to foster their resilience and to combat against the perspective of the abandonment of a lot of this area, which is, I'm going to say, we must refuse because of just spatial justice, but also for the negative effect we will suffer from the abandonment of these areas in terms of ecosystem services, in terms of historical, cultural, and traditional values. Thank you very much.
Thank you very much also to our colleagues from Urbino, L'Aquila, Molise, and Gran Sasso Science Institute. Also, this session has been very rich of information and things that have been discovered. And I think that all the workshop has been an occasion to see what is there behind what is related to some of the products of Italian products we know, and also products that are not known but are very precious, like truffle and saffron, and there are so many things to be discovered in Italy. So this also thanks to our guests, Japanese guests that attended this workshop, and I hope that this moment together will give the stimulus also to be curious and to come to visit Italy and see directly what Italy can offer, since Italy is not only big cities like Rome, Milan, Venice, Naples, but Florence, but many other small cities with singular identities, with stories, traditions, landscapes, art, architectures, so many things to be discovered all around Italy. So this is a kind of a promotional spot for Italy, but I believe that Italy worth a visit not only on the most famous places, but also in the more in the inland areas and all those places that are very rich of culture and traditions. Now I would leave thank you very much for our presenters. I would leave room to the rector of the University of Urbino for the final remarks.
I will not, thank you, Fabio. I will not summarize all the papers or the presentations, but again, I would like to take the opportunity to thank again the Commissioner General of the Expo and Ambassador since 2 days ago, probably, from what I understood, the new ambassador of Italian ambassador in Japan, Mario Vattani, for the collaboration he offered to our universities to present our research, as I said this morning, but also to let you know what we are doing in many other dimensions within our institutions. I think it was a very productive day that within which we enjoyed also the let's say the part where we socialized with Italian products, in particular truffles. So let me thank Dr. Giuseppe Cristini for all he did to bring truffles in Japan, and our colleagues from Perugia who taught us how to understand which is the best oil, olive oil, or give us some hints how to choose our preferred olive oil, let's say. So again, it's an opportunity for me also again to thank all the colleagues from all universities. And let me also say that along this day we always talked of Marche, Abruzzo and Umbria, and we never mentioned Molise, but it is there. and so sorry for this, for forgetting about it or forgetting to mention it. And so again, thank you very much, and I hope this you enjoyed, especially I'm talking to our guests, and I hope you will enjoy the rest of the expo in the next days. Thank you again, and I would say thank Fabio, because it was okay.